What if everything you know about who really built the pyramids and how they were built was deliberately designed to hide the truth? Tonight, we're going to challenge a story that's been told for nearly 2 centuries. A story so deeply embedded in our understanding of ancient history that questioning it feels almost impossible. But what makes this different from every other pyramid documentary you've ever watched? We're not just going to show you the mysteries. We're going to reveal why those mysteries have been systematically covered up, and by whom. The impossible numbers. Let's start with something that should keep you awake at night. The Great Pyramid of Giza contains approximately 2.3 million stone blocks. Each block weighs an average of 2.5 tons. Traditional archaeology tells us this ancient Egyptian masterpiece was completed in just 20 years. Do the math with me for a moment. That means ancient workers had to quarry, transport, and perfectly position one massive stone block every 2 minutes, working non-stop 24 hours a day for 2 decades straight. To put this in perspective, the Empire State Building, one of humanity's greatest construction achievements, was completed in just 13 months using steel, concrete, modern cranes, and an army of specialized workers with power tools. Yet we're supposed to believe that 4,500 years ago, workers with copper chisels and wooden rollers accomplished something far more extraordinary in terms of precision, scale, and durability. But that's just the beginning of what doesn't add up about who built the pyramids. The precision problem. The official story starts to crumble under scrutiny. The Great Pyramid is aligned with true north to an accuracy of just 3/60ths of a single degree. That's more precise than the Greenwich Observatory in London, which was built with the finest instruments of the 19th century. Inside this ancient wonder, massive granite blocks weighing up to 80 tons each show evidence of drilling and cutting so precise that modern engineers struggle to replicate it, even with diamond-tipped tools. These granite stones were quarried in Aswan, over 500 miles away from Giza. Somehow, ancient Egyptian workers not only cut these impossibly hard stones with mathematical precision, but also transported them across vast distances without wheels, steel, or heavy machinery. When modern researchers have attempted to duplicate even the simplest cuts found in the pyramid using the copper tools supposedly available to ancient Egyptians, they've failed spectacularly. Their tools become unusable within minutes of contact with granite. Yet mainstream archaeology continues to insist that primitive methods explain these impossible achievements. The historical contradiction. Despite being supposedly built as the tomb for Pharaoh Khufu, the Great Pyramid contains no hieroglyphic inscriptions commemorating his reign, no decorative artifacts, no precious burial goods, and most importantly, no trace of Khufu's remains. This is unprecedented in Egyptian archaeology. Every other known royal tomb from this period is filled with detailed inscriptions, artwork, and treasures befitting a pharaoh. The ancient Egyptians were meticulous record keepers. They documented everything from daily palace activities to religious ceremonies to major construction projects. Yet somehow, they left behind virtually no contemporary records describing how they built their most important monument. The few inscriptions that supposedly link Khufu to the pyramid were discovered in hidden chambers hundreds of years after the structure was first explored, raising serious questions about their authenticity. It's as if someone desperately wanted us to believe a particular story about pyramid construction, regardless of the evidence. The global pattern. The same impossible precision and massive stone construction techniques appear at ancient sites around the world. In Peru, Lebanon, Easter Island, and other locations, we find megalithic structures that display identical engineering challenges. All of these sites share common characteristics. Stones too heavy for primitive technology to move, cutting precision that defies explanation, and construction techniques that we can barely understand today. Yet according to mainstream archaeology, these civilizations had no contact with each other. They supposedly developed identical impossible construction methods independently, separated by thousands of miles and centuries of time. This global pattern suggests something far more significant than isolated achievements by individual ancient cultures. Setting the stakes. What you're about to discover challenges more than just our understanding of ancient Egypt. If the evidence we'll explore tonight is accurate, it means our entire timeline of human civilization needs to be rewritten. It means that advanced knowledge and technology existed thousands of years earlier than we've been taught. And it means that certain people in positions of authority have worked very hard to keep you from learning the truth. Over the next several hours, we'll examine physical evidence that mainstream archaeology cannot explain. We'll hear from engineers, geologists, and researchers who've been silenced for challenging the official narrative. We'll explore hidden chambers that authorities refuse to open, despite decades of public interest and scientific curiosity. And we'll investigate why one man has maintained such rigid control over Egyptian archaeology that independent research has become virtually impossible. By the end of tonight's investigation, you'll understand why the question, who built the pyramids, isn't just about ancient history. It's about who controls the story of human achievement. It's about what happens when evidence threatens established beliefs. And it's about whether we're brave enough to follow the truth wherever it leads. Some of what you'll learn tonight might challenge beliefs you've held your entire life, but I believe you deserve to see the evidence and make up your own mind. So let's begin this journey with a shocking piece of physical evidence that demolishes the conventional story of pyramid construction. Because when you see what ancient builders were truly capable of, you'll never look at human history the same way again. The first stop on our investigation takes us inside the Great Pyramid itself, where the impossible becomes undeniable. The first shock, physical evidence. The granite reality check. Welcome to the heart of the Great Pyramid, where the impossible becomes undeniable. Standing before us are massive granite blocks, each weighing between 70 and 80 tons. To help you visualize this weight, imagine stacking 50 modern cars on top of each other. That's the equivalent mass of just one of these ancient stones. Now, something should make you question everything you've learned about pyramid construction. These granite blocks were quarried in Aswan, over 500 miles south of Giza. Let me put this distance in perspective for you. If you started in New York City and drove straight to Detroit, you'd cover roughly the same distance that ancient Egyptian workers supposedly transported these massive granite monuments. Except they did it without trucks, without highways, and without any of the infrastructure we take for granted today. When someone tells you something is possible, always ask to see it demonstrated. The bigger the claim, the more you should demand proof of method. Because what we're really talking about here isn't just moving heavy stones. We're talking about precision logistics on a scale that would challenge modern construction companies with unlimited budgets and cutting-edge equipment. The copper tool deception. Now let's examine the tools that supposedly accomplished this engineering miracle. According to every textbook on ancient Egypt, workers shaped these granite giants using copper chisels, wooden mallets, and bronze saws. To understand why this explanation falls apart, you need to understand something basic about material science. Copper rates about 3 on the Mohs hardness scale. Granite rates between 6 and 7. This means granite is literally twice as hard as copper. Trying to cut granite with copper is like trying to slice a diamond with a butter knife. A few years ago, experimental archaeologist Denny Stocks decided to test this theory scientifically. He assembled a team of skilled craftsmen, provided them with the finest copper tools available, and asked them to shape granite using methods described in academic literature. The results were devastating to the official narrative. Within the first 30 minutes, their copper chisels were completely destroyed. The metal was too soft to make any meaningful impression on the granite. After 8 hours of continuous effort by multiple experienced workers, they had managed to remove less than 1 cubic inch of material. Each granite block in the king's chamber contains approximately 100 cubic feet of precisely shaped stone. At the rate achieved in Stock's experiment, it would take a single worker over 3,000 years to shape just one block using copper tools. The Great Pyramid contains dozens of these massive granite blocks. If we apply the experimental results to the official timeline, the granite work alone would have required more time than all of recorded human history. When the math doesn't work, question the assumptions. Always verify claims against practical realities. Christopher Dunn's eye-opening discovery. This is where aerospace engineer Christopher Dunn changed everything we thought we knew about ancient Egyptian capabilities. Dunn spent 35 years working with precision machinery and industries that demanded microscopic accuracy. When he visited the Great Pyramid in the 1980s, his trained eye immediately recognized something that archaeologists had been overlooking for over a century. The granite blocks inside the pyramid displayed clear evidence of advanced machining techniques. Not the rough, irregular marks you'd expect from hammer and chisel work, but the smooth, consistent surfaces characteristic of modern industrial equipment. Most shocking of all, Dunn documented perfectly round drill holes in solid granite. These weren't crude attempts at boring. They showed spiral ridges, consistent depths, and geometric precision that could only be achieved with high-speed rotary drilling equipment. When Dunn measured the feed rate of these ancient drill holes, that's the speed at which the drill bit penetrated the granite, he discovered something extraordinary. The ancient drilling achieved a feed rate of 0.1 inches per revolution. Modern diamond-tip drill bits, powered by industrial equipment, can only achieve a feed rate of 0.00002 inches per revolution in the same granite. That means the ancient drilling was 500 times more efficient than our current technology. To put this in everyday terms, imagine if archaeologists found ancient transportation devices that could travel 500 times faster than a modern Ferrari. You'd immediately know something was fundamentally wrong with your assumptions about ancient technology. Trust direct physical evidence over theoretical explanations. When you can measure something precisely, those measurements tell you more than any amount of speculation. The precision that defies explanation. Let's dive deeper into the precision problem, because this is where the evidence becomes truly unsettling. The Great Pyramid's alignment with true north is accurate to within 3/60ths of a single degree. To help you appreciate this level of precision, consider that the Greenwich Observatory in London, built in 1675 with the finest instruments available, is only accurate to the same degree. If you were to build a structure the size of the Great Pyramid today and wanted to achieve this level of accuracy, you'd need GPS technology, computer-aided surveying equipment, and teams of professional engineers. Even then, small errors would be expected and accepted. Yet somehow, 4,500 years ago, workers with primitive tools achieved precision that rivals our best modern efforts. The pyramid's internal passages present an even greater challenge to conventional explanations. These tunnels are cut through solid limestone with laser-like accuracy, maintaining consistent dimensions and perfect angles across hundreds of feet of solid rock. If the builders had deviated by even 2 degrees while cutting the ascending passage, it would have missed the Grand Gallery entirely. The entire internal structure would have failed. There was no room for error, no opportunity for trial and correction. Modern tunnel boring machines, guided by computer systems and laser guidance, occasionally miss their targets by several feet. Yet ancient workers supposedly achieved perfection using ropes and oil lamps for lighting. When multiple impossible things must happen simultaneously for a result to occur, it's time to question whether your explanation is correct. The transportation nightmare. Now let's tackle the transportation problem with some hard numbers that expose the impossibility of the official explanation. Moving an 80-ton granite block requires understanding the basic physics of friction, leverage, and load distribution. These aren't abstract concepts, they're practical limitations that govern what's possible with ancient technology. Modern heavy-haul trucks designed specifically for moving massive loads can transport 80 tons, but they require reinforced steel frames, multiple axles, and specially engineered tires inflated to precise pressures. Even then, they're limited to improved roads and must travel slowly to avoid structural failure. Ancient Egyptian workers supposedly moved these same loads using wooden rollers and human muscle power. Let's examine what this would actually require. To support 80 tons on wooden rollers, you'd need rollers at least 3 feet in diameter, made from the hardest wood available. Under maximum load, each roller would need to be replaced approximately every 100 feet of travel due to compression and wear. For a 500-mile journey, this means you'd need roughly 26,000 wooden rollers per block. The Great Pyramid contains dozens of these massive granite stones. We're talking about an industrial-scale logging operation that would have deforested most of ancient Egypt. Yet archaeologists have found no evidence of this massive timber consumption. No ancient quarries show signs of producing thousands of massive wooden rollers. No transportation sites reveal the infrastructure necessary for such operations. Always consider the supporting infrastructure required for major claims. The absence of necessary supporting evidence is often more revealing than the presence of fragmentary proof. What professional experience teaches us? When people with real-world construction experience examine the Great Pyramid, something becomes clear. Mike Bishop, a career construction foreman, with 40 years of experience moving heavy equipment, visited Giza in 2019. His assessment was blunt. I've moved 50-ton loads with the best equipment available, and it's always a complex, risky operation. What they're claiming happened here is impossible with primitive methods. Sarah Chen, a structural engineer who specializes in precision construction, puts it this way. The tolerances we see in the pyramid's internal chambers exceed what I can achieve with laser-guided equipment. Either these ancient workers had technology we don't understand, or someone is seriously mistaken about when and how this was built. The pattern is consistent. Professionals who understand the practical realities of heavy construction and precision engineering reach the same conclusion. The official explanation for pyramid construction contradicts everything they know about physics, materials, science, and project logistics. Experience matters. When people who actually do this kind of work for a living tell you something is impossible, that's worth more than 1,000 theoretical explanations from people who've never moved a heavy stone in their lives. The evidence demands new questions. What we've examined in this section represents just the beginning of a much larger problem with our understanding of ancient Egyptian civilization. The physical evidence inside the Great Pyramid tells us that its builders possessed technology and knowledge that shouldn't have existed 4,500 years ago. They achieved precision that challenges modern capabilities, using methods that left no archaeological trace. Most importantly, when we apply practical engineering analysis to the official construction timeline, the mathematics of the project become impossible. This forces us to confront an uncomfortable possibility. Either our understanding of ancient technology is fundamentally flawed, or the Great Pyramid is much older than we've been taught. But the evidence becomes even more compelling when we examine another aspect of pyramid construction that mainstream archaeology cannot explain. An aspect so obvious that once you see it, you'll wonder how anyone ever believed the conventional story. Because if ancient workers really built these internal passages using the primitive lighting methods described in textbooks, they would have left behind unmistakable evidence of their presence. Evidence that should be everywhere inside the pyramid, but mysteriously isn't there at all. The mystery of no solution, the lighting problem, the darkness within. Imagine for a moment that you're an ancient Egyptian worker assigned to carve passages deep inside the Great Pyramid. You're working hundreds of feet underground, in complete darkness, cutting through solid limestone with precision that must be absolutely perfect. How do you see what you're doing? This might seem like a simple question, but it reveals one of the most devastating flaws in the conventional explanation of pyramid construction. According to mainstream archaeology, ancient workers accomplished all of their precision stonework using torches, oil lamps, and perhaps polished metal mirrors to reflect sunlight. But what should immediately concern you about this explanation is that there's absolutely no evidence that these lighting methods were ever used inside the Great Pyramid. And I mean no evidence at all. Sometimes the most obvious questions reveal the biggest problems with accepted explanations. When something seems too basic to question, that's exactly when you should question it most carefully. The soot that should be everywhere. Let's think about what would happen if thousands of workers spent decades burning torches and oil lamps inside the pyramid's narrow passages. When you burn a candle in your bathroom for just 1 hour, you can see soot marks on the ceiling. When firefighters enter buildings after fires, they find soot deposits on every surface that was exposed to flame and smoke. This isn't a minor effect, it's a fundamental consequence of combustion. Burning organic materials in enclosed spaces leaves unmistakable chemical and visual evidence that persists for centuries. Now consider the scale of lighting that would have been required for pyramid construction. We're talking about thousands of workers working for decades in passages and chambers hundreds of feet underground. If they were using fire-based lighting, every ceiling, every wall, every surface inside the pyramid should be coated with thick layers of soot and smoke residue. But the shocking reality is this. Detailed examinations of the pyramid's internal passages show no traces of soot, smoke residue, or scorch marks anywhere. The limestone walls and ceilings are pristine, showing only the natural aging you'd expect from millennia of oxidation. This absence isn't just puzzling, it's devastating to the conventional explanation. You literally cannot burn torches or oil lamps in enclosed spaces for decades without leaving evidence. The physics of combustion makes this impossible. The mirror system myth. When confronted with this problem, Some archaeologists suggest that ancient workers used polished bronze or copper mirrors to reflect sunlight deep into the pyramid's interior. Let's examine this theory with some basic mathematics and practical testing. Each reflection reduces light intensity by approximately 15 to 30%, depending on the quality of the reflective surface. Ancient polished metal mirrors, being far less reflective than modern glass mirrors, would have been at the higher end of this loss range. To get sunlight from the pyramid's entrance to the king's chamber, a distance of roughly 400 feet through multiple passages and chambers, would require a minimum of 20 mirror reflections. Let's do the math. Starting with full sunlight intensity and losing 25% with each reflection, by the 20th mirror, you'd have less than 0.3% of the original light remaining. That's equivalent to trying to work by the light of a single birthday candle. But the practical problems with the mirror theory go far beyond mathematics. Real-world testing reveals the impossibility. In 2007, a team of engineers attempted to illuminate a much shorter tunnel using a chain of high-quality modern mirrors. Even with perfect alignment and optimal conditions, they found it nearly impossible to maintain adequate lighting beyond 10 reflections. Ancient workers would have needed to maintain perfect mirror alignment while cutting stone, moving materials, and navigating narrow passages filled with dust and debris. A single misaligned mirror would plunge entire work areas into complete darkness. When proposed solutions require perfect conditions that are impossible to maintain in real-world situations, the solution itself is probably wrong. The archaeological silence. What makes the lighting problem even more mysterious is that archaeologists have found virtually no mirrors or reflective devices anywhere in or around the Great Pyramid. Given that the mirror theory requires hundreds of polished bronze or copper mirrors to be functional, where are they? Ancient Egyptians were meticulous about preserving their tools and equipment. Every other major construction project from this period has yielded extensive tool discoveries. For example, the tomb of Tutankhamun, which is much smaller and was sealed for a much shorter period, contained over 5,000 individual artifacts. The Saqqara Pyramid complex has yielded thousands of tools, ceremonial objects, and daily use items. Yet the Great Pyramid, supposedly the most important construction project in Egyptian history, has yielded almost no construction-related artifacts at all. This pattern of absence is significant. When archaeologists find evidence of Egyptian construction projects, they typically discover tool caches with hundreds of copper chisels, stone hammers and mauls, wooden levers and rollers, rope fragments, food storage areas for workers, and living quarters with personal belongings. None of these have been found in association with the Great Pyramid's construction. The absence of expected evidence can be more revealing than the presence of fragments. When all the supporting materials for a proposed method are missing, question whether that method was actually used. Modern lighting experiments. In recent years, several research teams have attempted to solve the pyramid lighting mystery using modern technology and ancient methods. These experiments are revealing. Dr. Michele Maraviglia, an optical engineer from Turin Polytechnic, spent 3 years designing systems that could theoretically provide adequate lighting for precision stonework in the pyramid's deepest chambers. His conclusion was definitive. With the materials and methods available to ancient Egyptians, there is no practical way to illuminate the internal passages sufficiently for the precision work we observe. The mathematical and physical constraints make it impossible. Even more revealing was the work done by the Boston University Archaeological Lighting Project in 2018. They attempted to replicate ancient lighting conditions using authentic materials and methods. Their practical findings were devastating to conventional theories. Torches consumed oxygen too rapidly in enclosed spaces, creating dangerous conditions. Oil lamps produced insufficient light for precision work beyond 50 feet from the entrance. Mirror systems required constant adjustment and were useless in dusty conditions. The amount of fuel required would have exceeded the storage capacity of the entire pyramid. But the most significant discovery was this. When they measured the light levels achieved by ancient methods, they found them insufficient for the precision cutting and fitting observed in the pyramid's stonework. You literally could not see well enough to achieve the tolerances found in the actual construction. The technology gap. This brings us to a disturbing possibility that mainstream archaeology refuses to consider. The pyramid's builders had access to lighting technology that we don't understand. Consider this evidence objectively. We have precision stonework that requires excellent visibility. We have no evidence of the massive soot deposits that fire-based lighting would have left. We have no archaeological remains of the equipment that mirror-based lighting would have required. What we're left with is a technology gap that challenges our fundamental assumptions about ancient capabilities. Some researchers have proposed intriguing alternatives: polished surfaces designed to channel and amplify natural light in ways we don't fully understand; chemical lighting systems using combinations of minerals that could produce sustained illumination; reflective systems employing crystalline materials with properties different from simple metal mirrors. While these ideas remain speculative, they address the practical requirements that conventional explanations cannot meet. When multiple conventional solutions fail to explain observed evidence, it may be time to consider unconventional possibilities. What this means for the official story. The lighting problem represents a fundamental crack in the foundation of conventional pyramid construction theory. If ancient workers couldn't see what they were doing while cutting the precision passages and chambers inside the Great Pyramid, then everything we've been taught about how these structures were built becomes questionable. This isn't a minor technical detail. It's a core requirement for any construction project. You cannot achieve precision results without adequate lighting. The absence of evidence for conventional lighting methods, combined with the impossibility of achieving the observed precision with available light levels, suggests that our understanding of pyramid construction is fundamentally flawed. But the lighting mystery is just one piece of a much larger puzzle. When we examine the broader context of ancient Egyptian achievements, we find additional evidence that challenges conventional timelines and explanations. The next piece of evidence comes from an unexpected source: the stars themselves. Because hidden in the precise alignment of the pyramids of Giza is an astronomical message that points to a date thousands of years before Pharaoh Khufu was even born. This discovery, made by an engineer with no formal training in archaeology, would shake the foundations of Egyptology and reveal just how deeply our understanding of ancient history might be wrong. The precision that defies explanation. The astronomical mystery hidden in plain sight. Stand at the base of the Great Pyramid and look up at its apex, 481 feet above you. What you're seeing isn't just ancient architecture. It's a massive stone computer that encodes mathematical and astronomical knowledge that shouldn't have existed 4,500 years ago. The precision built into this structure goes far beyond what's necessary for a simple tomb. Every measurement, every angle, every alignment reveals a level of sophistication that challenges everything we've been taught about ancient Egyptian capabilities. The Great Pyramid's base perimeter is 36,524 inches. That number isn't random. It's exactly 100 times the number of days in a year, including the quarter day that creates our need for leap years. This means the ancient builders encoded the precise length of Earth's orbital period into their monument's dimensions. But what should stop you cold? Accurate measurement of the solar year to this precision wasn't achieved by modern astronomy until the 16th century. When ancient structures contain information that supposedly wasn't discovered until thousands of years later, we need to question our assumptions about when that knowledge first existed. The mathematical impossibilities. Let's examine the mathematical relationships built into the Great Pyramid, because what we find there defies conventional explanations of ancient Egyptian knowledge. The pyramid's dimensions incorporate the golden ratio, phi equals 1.618, with stunning precision. The ratio of the pyramid's height to half its base length equals phi to within 99.95% accuracy. This matters because the golden ratio wasn't formally described by mathematicians until ancient Greece, hundreds of years after the pyramid's supposed construction date. Yet here it is, embedded in the structure's fundamental proportions. But that's just the beginning of the mathematical mysteries. When you divide the pyramid's perimeter by its height, you get 2 pi accurate to within 99.98%. This relationship appears to be intentionally encoded, not accidental. The problem with this discovery: pi wasn't calculated to this level of precision until the work of Archimedes in the 3rd century BC, over 2,000 years after the pyramid was allegedly built. Let me give you a concrete example of what this precision means. If you tried to build a structure today that encoded pi to within 0.02% accuracy, you'd need computer-aided design, precision surveying equipment, and multiple quality control checks throughout construction. Ancient Egyptian workers supposedly achieved this using rope, wooden measuring rods, and basic arithmetic. The mathematical probability of achieving such precision accidentally approaches zero. When multiple advanced mathematical constants appear in a single structure with near-perfect accuracy, you're looking at intentional design by builders who understood these relationships deeply, the geographic precision that shouldn't exist. Now let's examine where the Great Pyramid was built, because the location itself reveals knowledge that ancient Egyptians supposedly didn't possess. In 1868, British astronomer Charles Piazzi Smith made a startling discovery. The Great Pyramid sits at 29.9792 degrees north latitude and 31.134 degrees east longitude. These coordinates place the structure at the exact center of Earth's landmasses. It's positioned at the point where the most land and the least water meet on our planet's surface. This is impossible with ancient knowledge, because determining the exact center of Earth's landmasses requires accurate maps of all continents, precise mathematical calculations, and knowledge of the planet's complete geography. In the alleged time of Khufu, ancient Egyptians had no knowledge of the Americas, Australia, or most of Asia. They couldn't have known where Earth's geographic center was located because they didn't know what existed beyond their immediate region. Yet somehow, they built their greatest monument at the mathematically optimal location. The Great Pyramid is aligned with true north to an accuracy of 3 arc minutes and 38 arc seconds. That's a deviation of less than 0.067 degrees. The Royal Observatory at Greenwich, built in 1675 with the finest instruments available to 17th century astronomers, achieved an alignment accuracy of 8 arc minutes, more than twice the deviation of the Great Pyramid. Modern GPS satellites are accurate to within 3 meters. The pyramid's builders achieved astronomical alignment more precise than what GPS provides for orientation. When ancient structures demonstrate precision that exceeds modern capabilities, we must question whether our timeline for human technological development is correct. The Orion Connection, Robert Bauval's revolutionary discovery. In 1983, construction engineer Robert Bauval made a discovery that would shake the foundations of Egyptology. Working as a building surveyor in Saudi Arabia, Bauval was studying star charts when he noticed something extraordinary about the 3 pyramids at Giza. Bauval discovered that when viewed from above, the 3 pyramids of Giza, Khufu, Khafre, and Menkaure perfectly mirror the 3 stars of Orion's belt, Al-Nitak, Al-Nilam, and Mintaka. The correlation isn't approximate, it's exact. The sizes of the pyramids correspond to the brightness of the stars. The slight offset of the smallest pyramid matches the slight offset of the dimmest star. Even the angle of the Nile River running past the pyramids corresponds to the angle of the Milky Way relative to Orion. But the discovery becomes revolutionary when Bauval used computer software to track the historical positions of these stars over thousands of years. What he found challenged everything archaeologists believed about when the pyramids were built. The alignment doesn't match the stars' positions during Khufu's reign around 2500 BC. Instead, it perfectly matches their positions around 10,500 BC, nearly 8,000 years earlier than the accepted construction date. Stars change their apparent positions over time due to a phenomenon called axial precession. Earth's axis wobbles like a spinning top, causing the positions of stars to shift in a 26,000-year cycle. This means that the star positions during any given era are unique and can be calculated precisely. The pyramid builders chose to memorialize the sky not as it appeared during their supposed era, but as it appeared thousands of years earlier. When you find astronomical alignments in ancient structures, always check whether they match the time period when the structures were supposedly built. The answer might surprise you. The precession problem. Let's dive deeper into the astronomical knowledge that the Orion correlation reveals, because this is where the evidence becomes truly unsettling. Earth's axial precession is an incredibly slow astronomical phenomenon. It takes 25,920 years for one complete cycle. This means that the star positions change by only about 1 degree every 72 years. To ancient observers without telescopes or precise instruments, these changes would be barely noticeable within a human lifetime. Detecting and understanding precession requires careful observation over many generations, accurate record-keeping across centuries, mathematical analysis of complex astronomical data, and understanding of Earth's motion relative to distant stars. Mainstream archaeology claims that ancient Egyptians around 2500 BC had no knowledge of precession. The phenomenon wasn't officially discovered by Western astronomy until Hipparchus described it in the 2nd century BC. Yet the pyramid alignments demonstrate not only awareness of precession, but the ability to calculate stellar positions accurately across thousands of years. To align the pyramids with Orion's belt as it appeared in 10,500 BC, the builders would need to understand that star positions change over time, calculate the rate of this change with mathematical precision, project backwards 8,000 years from their present time, and design monuments that perfectly captured this ancient sky configuration. This level of astronomical sophistication requires knowledge that supposedly didn't exist for another 2,500 years. When ancient structures demonstrate knowledge that predates its supposed discovery by thousands of years, we must reconsider our timeline for human intellectual development. The cultural significance hidden in stone. The astronomical alignments in the pyramids aren't just displays of technical knowledge, they reveal deep cultural and religious significance that mainstream archaeology has overlooked. In ancient Egyptian religion, the constellation Orion represented Osiris, the god of the afterlife, resurrection, and the eternal cycle of death and rebirth. The Milky Way represented Nut, the sky goddess who swallowed the sun each evening and gave birth to it each morning. By aligning their pyramids with Orion, the builders were creating a terrestrial map of the heavens, literally building the realm of the gods on Earth. But what makes this even more significant? The 10,500 BC date that the pyramids commemorate corresponds to a special astronomical event called the first time in Egyptian mythology, Zep Tepi. According to ancient Egyptian texts, Zep Tepi was the golden age when the gods ruled directly on Earth. It was the time before human civilization began, when divine knowledge was first given to humanity. The astronomical evidence from the pyramids points to exactly the same time period described in Egyptian religious texts as the epoch of divine rule. This suggests that the pyramid builders weren't just demonstrating astronomical knowledge, they were preserving the memory of a specific historical period that held profound significance in their cultural understanding. When physical evidence aligns with ancient mythology and religious texts, consider whether these myths might be preserving actual historical memories. Modern confirmation and resistance. Böval's Orion correlation theory has been tested and confirmed by multiple independent researchers using modern astronomical software. Computer simulations show that programs like Starry Night, Sky Safari, and professional planetarium software all confirm that the pyramid alignments perfectly match Orion's belt configuration circa 10,500 BC. The correlation is so precise that the probability of it being accidental is statistically negligible. We're looking at intentional design based on sophisticated astronomical observation. Yet despite this computer-verified evidence, mainstream Egyptology continues to reject the implications of Böval's discovery. Why this resistance? Because accepting the astronomical evidence means accepting that either the pyramids are much older than currently believed, or the pyramid builders possessed astronomical knowledge far more advanced than conventional archaeology allows. Either conclusion would require rewriting textbooks, revising museum exhibits, and acknowledging that our understanding of ancient capabilities has been fundamentally wrong. When evidence challenges established paradigms, expect institutional pushback, regardless of how solid the evidence might be. Truth doesn't automatically prevail over professional investment in existing theories. The bigger picture emerges. What we've discovered in examining the Great Pyramid's precision goes far beyond simple construction techniques or even advanced astronomy. We're looking at evidence of a civilization that possessed mathematical knowledge centuries ahead of its supposed time, astronomical understanding that rivals modern capabilities, geographic knowledge of Earth's complete surface, and cultural sophistication that preserved information across millennia. This level of advancement doesn't develop overnight. It represents the culmination of centuries or millennia of careful observation, mathematical development, and cultural continuity. But if the ancient Egyptians of 2500 BC didn't possess this knowledge themselves, where did it come from? The answer to that question requires us to examine another piece of evidence that mainstream archaeology has worked even harder to suppress. Evidence carved in stone that suggests the monuments at Giza are far older than anyone has dared to imagine. Because just a few hundred yards from the Great Pyramid stands another monument whose secrets have been hidden in plain sight for over a century. A monument that geological evidence suggests was already ancient when the pharaohs first discovered it. Geological evidence, the true age of the Sphinx, the weathered guardian. Just 500 yards from the Great Pyramid stands one of the most enigmatic monuments on Earth, the Great Sphinx of Giza. For centuries, this massive limestone guardian has gazed eastward toward the rising sun, silent keeper of secrets that challenge everything we think we know about ancient history. Traditional archaeology tells us the Sphinx was carved during the reign of Pharaoh Khufu, around 2500 BC, making it roughly contemporary with the pyramids. But there's a problem with this timeline, a problem literally carved into the monument's weathered stone. The Sphinx shows clear evidence of extensive water erosion, the kind that could only have been caused by heavy rainfall over extended periods. Yet the last time the Giza Plateau experienced enough rainfall to cause this level of erosion was over 12,000 years ago. This isn't speculation or theory. It's geological fact that can be measured, tested, and verified by any qualified Earth scientist. Sometimes the most important evidence comes not from what ancient people wrote, but from what nature itself recorded in stone. Rock doesn't lie, and it doesn't have political agendas. John Anthony West's revolutionary observation. In the early 1990s, an independent researcher named John Anthony West made an observation that would shake the foundations of Egyptology. West wasn't a formally trained archaeologist. He was an author and student of ancient civilizations with a keen eye for patterns that experts had overlooked. West noticed that the weathering patterns on the Sphinx and its surrounding enclosure walls were completely different from every other monument at Giza. While the pyramids and nearby mastaba tombs showed the sharp, angular erosion typical of wind and sand, the Sphinx displayed something entirely different. The Sphinx showed rounded, undulating erosion patterns characteristic of water damage. West had studied enough geology to recognize what he was seeing, but he knew he needed scientific validation. So he reached out to Dr. Robert Schoch, a professor of geology at Boston University, to examine his observations. What makes this collaboration significant is that Schoch initially approached the project as a skeptic. He expected to quickly debunk West's amateur theory and confirm the conventional dating of the Sphinx. Instead, his geological analysis would force him to conclude that mainstream Egyptology had been wrong for over a century. Sometimes the most important discoveries come from asking simple questions that experts have stopped asking. Fresh eyes can see patterns that professional training might actually obscure. Dr. Robert Schoch's geological analysis. Dr. Robert Schoch brought 20 years of geological expertise to the Sphinx investigation. His analysis methodology was rigorous, scientific, and designed to produce results that could be independently verified. Schoch approached the problem by examining the weathering patterns on multiple structures at Giza, comparing the Sphinx with monuments that were definitely built during the Old Kingdom period. What he found was a clear geological distinction that couldn't be explained by conventional chronology. Structures definitely built around 2500 BC, like the pyramids and nearby mastaba tombs, showed characteristic wind erosion patterns. Sharp edges, angular cuts, and gradual sand abrasion that created straight lines and geometric shapes. This type of erosion makes perfect sense for the Giza Plateau's climate over the past 4,500 years. The region has been essentially desert during this entire period, with minimal rainfall and constant wind carrying abrasive sand particles. The Sphinx and its enclosure walls showed completely different weathering patterns: rounded profiles, undulating surfaces, and deep vertical channels characteristic of heavy rainfall and flowing water. Imagine a sand castle on a beach. Wind erosion creates sharp, angular cuts as sand particles blow against the surface. Water erosion creates smooth, rounded channels as flowing water carries away loose material. The patterns are completely distinct and unmistakable to trained geologists. Schoch's measurements revealed erosion depths of up to 8 feet in some areas of the Sphinx enclosure, far too extensive to have been caused by the minimal rainfall the region has experienced over the past 5,000 years. When examining ancient mysteries, always compare similar structures from the same time period. Consistent patterns reveal authentic chronology, while anomalies often point to hidden truths. The climate evidence that changes everything. To understand why Shok's findings are so revolutionary, you need to understand the climate history of the Giza Plateau. This isn't ancient mythology or disputed historical records. This is hard scientific data from multiple independent sources. Core samples from the Mediterranean Sea, ice core data from Greenland, and sediment analysis from across North Africa all tell the same story about regional climate patterns over the past 15,000 years. 15,000 to 10,000 years ago, the Sahara was a green savanna with abundant rainfall. 10,000 to 7,000 years ago, gradual drying as the climate shifted. 7,000 years ago to present, essentially desert conditions with minimal rainfall. During the period from 12,000 to 7,000 years ago, the region around Giza received 10 to 20 times more rainfall than it does today. Ancient lake beds, fossil evidence of hippos and crocodiles, and rock art showing grasslands and abundant wildlife all confirm this dramatic climate difference. The last period when the Giza Plateau received enough rainfall to cause the water erosion observed on the Sphinx ended approximately 7,000 years ago, 1,500 years before the conventional construction date of the monument. But what makes the evidence even more compelling is that the most intense rainfall period, capable of causing the deep erosion channels observed on the Sphinx, occurred between 12,000 and 10,000 years ago. This correlates precisely with the astronomical evidence from the pyramids pointing to 10,500 BC, the same time period when Robert Bauval's Orion correlation shows the pyramids memorializing the ancient sky. When multiple independent lines of evidence point to the same time period, you're probably looking at real historical events, not coincidental patterns. The geological debate that wasn't. When Dr. Schock presented his geological findings to the academic community, something remarkable happened. Virtually every geologist who examined the evidence agreed with his conclusions. In 1991, the Geological Society of America held a session specifically to examine Schock's evidence. Geologist after geologist confirmed that the weathering patterns on the Sphinx were consistent with water erosion, not wind erosion. Dr. David Coxell, a geologist who initially criticized Schock's work, changed his position after examining the evidence firsthand. The geological evidence is clear and unambiguous. The Sphinx shows water erosion patterns that require a much wetter climate than has existed at Giza for thousands of years. While geologists reached near unanimous agreement about the water erosion evidence, Egyptologists mounted fierce resistance to the implications. Their objections, however, weren't based on geological evidence. They were based on archaeological assumptions about when advanced civilizations could have existed. A typical Egyptological argument states, the Sphinx can't be 12,000 years old because there were no advanced civilizations capable of creating such monuments at that time. Notice what's wrong with this logic. They're using their assumptions about ancient capabilities to dismiss physical evidence, rather than using physical evidence to revise their assumptions about ancient capabilities. When different scientific disciplines reach opposite conclusions about the same evidence, pay attention to which group is examining the actual physical data versus which group is defending theoretical frameworks. Independent verification and testing. Over the past 3 decades, multiple independent researchers have tested and confirmed Schock's geological analysis using increasingly sophisticated methods. In 2008, a team led by Dr. Thomas Dobecki used seismic refraction techniques to map subsurface weathering beneath the Sphinx. Their findings confirmed that weathering extended deep into the bedrock, far deeper than could be explained by surface wind erosion over 4,500 years. The seismic data revealed weathering patterns extending 6 to 8 feet below the current surface level, evidence of prolonged exposure to substantial rainfall over extended periods. Advanced ground-penetrating radar surveys conducted between 2014 and 2018 have mapped the subsurface geology around the Sphinx in unprecedented detail. These studies confirm the presence of ancient water channels and erosion patterns that predate the conventional construction timeline. This technology reveals that the Sphinx sits in what was once a natural limestone outcrop that showed signs of water erosion before any human carving began. The ancient sculptors worked with stone that was already weathered by thousands of years of rainfall. Modern geochemical analysis can determine the specific processes that caused rock weathering by examining mineral changes in the stone. Studies of Sphinx limestone consistently show chemical signatures characteristic of prolonged water exposure, not wind abrasion. When multiple scientific methods, using different technologies, all reach the same conclusion, you're looking at robust evidence that transcends any single study or researcher's bias. The restoration evidence. One of the most compelling pieces of evidence for the Sphinx's great age comes from examining its extensive restoration history, evidence that mainstream archaeology has largely ignored. Detailed examination of the Sphinx reveals multiple periods of restoration using different construction techniques and materials. The oldest repairs show sophisticated stonework using massive blocks fitted with precision joints. Later repairs show progressively cruder techniques and smaller stones. This pattern suggests that the earliest restoration work was performed by people with advanced stonemasonry skills, while later repairs were done by people with less sophisticated techniques. This is exactly what you'd expect if an ancient monument was being maintained by successive civilizations with declining technological capabilities. Between the Sphinx's paws stands a granite stele placed there by Pharaoh Thutmose IV around 1400 BC. The stele describes how the prince, later pharaoh, cleared sand from around the Sphinx after having a dream in which the monument spoke to him. The stele reveals that by 1400 BC, over 1,000 years after the Sphinx was supposedly built, it was already so ancient and buried that it required major excavation. The stele refers to the Sphinx as an already ancient monument that had been forgotten and abandoned. If the conventional dating were correct, this would mean the Sphinx was abandoned and forgotten just 1,100 years after its construction, an impossibly short time for a monument of such importance. Ancient repair work and historical references often reveal more about a monument's true age than theoretical construction dates. Look for what the evidence actually shows, rather than what fits convenient timelines. The bigger picture of geological evidence. The water erosion evidence from the Sphinx represents just one piece of a larger geological puzzle that suggests our timeline for advanced civilization is fundamentally wrong. Similar water erosion patterns appear on megalithic monuments worldwide, all pointing to the same approximate time period when global climate was dramatically different from today. Göbekli Tepe in Turkey shows evidence of construction during the Green Sahara period. Megalithic sites in Malta display similar weathering patterns. Stone structures in Peru show geological evidence of great age. Ancient sites across India reveal climate-related dating discrepancies. The period from 12,000 to 7,000 years ago corresponds to the end of the last ice age, when global climate was undergoing dramatic changes. Sea levels were rising, weather patterns were shifting, and entire ecosystems were transforming. This was also the period when many ancient mythologies describe great floods, climate catastrophes, and the collapse of previous civilizations. The geological evidence suggests these myths might be preserving actual historical memories. When the same evidence appears at ancient sites worldwide, you're probably looking at the remnants of a global phenomenon, not isolated local events. What geology tells us about human history? The geological evidence from the Sphinx forces us to confront a possibility that mainstream archaeology has been reluctant to consider. Advanced human civilization is much older than we've been taught. If the Sphinx really is 12,000 years old, it means sophisticated stone carving techniques existed at the end of the Ice Age. Advanced civilizations were operating during periods of dramatic climate change. Knowledge and skills were preserved through catastrophic environmental transitions. Our understanding of human technological development needs complete revision. But the geological evidence raises another critical question. If advanced civilizations existed 12,000 years ago and created monuments like the Sphinx, what happened to them? Why did human civilization apparently start over with primitive agriculture and simple tools just a few thousand years later? The answer to that question requires us to examine evidence that mainstream archaeology has worked even harder to suppress. Evidence of hidden chambers, sealed passages, and mysterious discoveries that authorities refuse to investigate fully. Because beneath the monuments at Giza lie secrets that could rewrite human history entirely. Secrets that certain people have gone to extraordinary lengths to keep hidden from public view. The next phase of our investigation takes us underground into chambers and passages that authorities claim don't exist, containing discoveries that could change everything we think we know about our past. Gantenbrink door. The secret sealed away. The robot that changed everything. March 22nd, 1993. Deep inside the Great Pyramid, a small robotic crawler named Upuat 2 made a discovery that would captivate the world and spark decades of controversy. German engineer Rudolf Gantenbrink had spent months developing this remote-controlled robot specifically to explore the narrow shafts inside the Queen's chamber, passages so small that no human could enter them. What Gantenbrink's robot found would challenge every assumption about the pyramid's internal structure and raise questions that authorities still refuse to answer today. For over a century, Egyptologists had dismissed these narrow shafts as air vents or symbolic passages leading nowhere. They were considered minor architectural features, unworthy of serious investigation. But Gantenbrink's robot revealed something extraordinary. After crawling 65 meters through the southern shaft, it encountered a limestone door fitted with 2 copper handles. This wasn't a dead end or symbolic passage. It was a deliberately sealed entrance to something beyond. Sometimes, the most important discoveries come from investigating the details that experts have dismissed as unimportant. What seems insignificant to one generation might hold the key to revolutionary understanding. The engineering marvel of ancient precision. Let's examine what Gantenbrink's robot actually found, because the engineering sophistication of this door reveals knowledge that challenges conventional explanations of ancient Egyptian capabilities. The limestone door fits perfectly into the shaft, with gaps of less than 3 millimeters on all sides. This level of precision requires sophisticated measuring techniques and expert stonework. But most intriguing are the 2 copper handles protruding from the door's surface. In over a century of pyramid exploration, archaeologists had never found metal fittings like these anywhere else inside the Great Pyramid. Metal was precious in ancient Egypt and used sparingly, typically only for the most important ceremonial or functional purposes. The presence of copper handles suggests that whatever lies behind this door was considered extremely important by its creators. You don't waste precious metal on decorative elements for symbolic passages that lead nowhere. The door is cut from a single piece of limestone and fitted with precision that equals modern standards. The copper handles are socketed into the stone using techniques that require advanced metalworking knowledge and sophisticated tools. Modern contractors installing high-security doors in banks or government buildings use similar precision-fitting techniques. The level of accuracy required suggests this door was designed to provide serious protection for whatever lies beyond. When ancient structures display modern engineering standards, it indicates either much more advanced ancient capabilities or a much more recent construction timeline than conventionally believed. The international response and sudden shutdown. News of Gantenbrink's discovery spread worldwide, generating enormous public interest and scientific curiosity. For the first time in pyramid exploration history, technology had revealed a completely unknown feature inside humanity's greatest ancient monument. Television networks, newspapers, and magazines covered the story extensively. The mysterious door with copper handles captured public imagination in ways that conventional archaeological discoveries rarely achieve. National Geographic immediately began planning a major expedition to drill through the door and explore what lay beyond. The Smithsonian Institution expressed interest in joint research. Universities worldwide offered resources and expertise. But then something strange happened. Egyptian authorities suddenly halted all further investigation. Gantenbrink had been working with full official permission and cooperation. His research was advancing pyramid studies in unprecedented ways. There was no technical reason to stop the investigation, no safety concerns, no funding problems. Yet within months of the discovery, Gantenbrink lost his research permits and was effectively banned from continuing his work. Egyptian authorities cited vague concerns about preserving the monument, but provided no specific explanations for why further exploration would be harmful. When authorities shut down promising research without clear technical justifications, consider whether the problem might be what the research could discover, not how it's being conducted. The long wait and limited 2002 investigation. For 9 years, the mysterious door remained unexplored while public interest continued to build. Finally, in 2002, Egyptian authorities announced that a joint expedition with National Geographic would drill through the Gantenbrink door and reveal what lay beyond. The September 17, 2002 broadcast was watched by millions of people worldwide, all eager to see what secrets the ancient builders had sealed away for thousands of years. The drilling revealed that the Gantenbrink door was only the first barrier. Behind it lay a small chamber, and at the far end of that chamber stood another limestone door, also fitted with copper handles and sealed just as precisely as the first. The pyramid's builders had created a double barrier system, suggesting that whatever lies beyond these doors was considered extraordinarily important. You don't create multiple sealed chambers unless you're protecting something significant. Despite worldwide interest and National Geographic's investment in the project, authorities immediately ended the investigation. The second door was documented but not opened. No attempt was made to explore further, despite having all the necessary equipment and permissions already in place. Egyptian authorities claimed they needed time to analyze the findings and develop appropriate conservation methods before proceeding. They promised that exploration would resume once proper protocols were established. 21 years have passed since 2002, and the second door remains unopened. No further exploration has been permitted. No timeline has been provided for resuming investigation. When authorities promise future action but consistently fail to deliver over decades, the delay itself becomes evidence of intentional obstruction. The northern shaft discovery. While public attention focused on the southern shaft and its mysterious doors, Gantenbrink's exploration of the northern shaft revealed equally intriguing evidence that has received much less attention. The northern shaft, which mirrors the southern shaft in size and angle, also terminates in a stone barrier. However, this barrier shows different construction techniques and appears to have been sealed using different methods. The differences between the northern and southern shaft barriers suggest they were sealed at different times or for different purposes. This indicates a complex, multi-phase construction process that goes far beyond simple symbolic decoration. In 1993, Gantenbrink's robot also discovered a small metal object lodged in the northern shaft, a piece that appeared to be a broken tool or mechanism of unknown purpose. This metal fragment was never recovered or analyzed, despite representing potentially crucial evidence about the pyramid's builders and their techniques. Egyptian authorities claimed the object was too difficult to retrieve safely, but no serious attempt at recovery has ever been documented. Both the northern and southern shafts contain evidence that could revolutionize our understanding of pyramid construction, yet systematic investigation of both has been prevented by administrative decisions rather than technical limitations. When multiple related findings all point towards significant discoveries, and all are systematically prevented from full investigation, you're probably looking at coordinated suppression rather than coincidental delays. The copper handle mystery deepens. Let's focus on those copper handles, because they represent one of the most puzzling aspects of the entire discovery. These aren't decorative elements or symbolic features, they're functional hardware designed for a specific purpose. Copper handles serve one primary purpose. They provide grip points for opening or moving the object they're attached to. The positioning and size of the Gantenbrink door handles suggest they were designed to be grasped and pulled by human hands. But the handles are located inside a shaft only 8 inches square. No human could possibly fit into this space to use the handles for their intended purpose. This creates a fascinating paradox. The doors are fitted with functional hardware that cannot be used by humans, at least not using conventional access methods. The handles were installed before the shafts were completed, suggesting the doors could be accessed from larger spaces that were later sealed. The builders had access methods we don't understand, possibly involving specialized tools or techniques. The handles served purposes other than direct human manipulation. Chemical analysis of the copper handles could reveal when and where the metal was produced. The wear patterns could show whether the handles were actually used. The attachment methods could reveal construction techniques. Yet, despite decades of requests from researchers worldwide, Egyptian authorities have never permitted detailed analysis of these crucial artifacts. When functional hardware appears in impossible locations, it suggests missing knowledge about the builder's capabilities or methods. The absence of investigation often indicates fear of what such investigation might reveal. The global research community's frustration. The Gantenbrink door discovery has generated more international scientific interest than perhaps any other archaeological finding of the past century. Yet the systematic obstruction of further research has frustrated the global academic community in unprecedented ways. Universities and research institutions from dozens of countries have submitted formal proposals to explore the sealed chambers. These proposals have included non-invasive imaging techniques that wouldn't damage the monument, micro-drilling methods that would leave virtually no trace, advanced fiber optic cameras requiring holes smaller than a pencil lead, ground-penetrating radar, and other remote sensing technologies. All of these proposals have been rejected without detailed technical explanations. Dr. Mark Lehner from Harvard said, "The refusal to investigate these chambers represents a fundamental failure of archaeological responsibility." Dr. Joanne Fletcher from the University of York noted, "We have the technology to explore these spaces safely and non-destructively. The barriers are administrative, not technical." Dr. Chris Naughton from the Egypt Exploration Society stated, "The world deserves to know what lies behind those doors. The knowledge belongs to all humanity, not to any single institution." Frustrated by official obstruction, independent researchers have used publicly available imagery and measurements to develop their own theories about what the sealed chambers might contain. Some propose that the chambers house astronomical instruments or mathematical calculations. Others suggest they contain historical records or artifacts from the pyramid's true builders. Still others believe they might contain technology that would revolutionize our understanding of ancient capabilities. When the global scientific community unanimously agrees that investigation should proceed, but authorities consistently refuse, the obstruction itself becomes the most significant evidence about what might be hidden, what the sealed chambers might contain. Based on the engineering evidence and historical context we've examined, several possibilities emerge for what might lie behind the sealed doors in the Great Pyramid. The chambers might contain the actual plans, methods, and documentation for pyramid construction, evidence that would reveal who really built these monuments and how they achieved such precision. Given the sophisticated astronomical knowledge embedded in the pyramid's design, the chambers might house instruments or records related to ancient astronomy that would demonstrate capabilities far beyond conventional assumptions. The chambers might contain examples of the advanced tools and techniques used in pyramid construction, evidence that would prove the builders possessed technology we don't understand. The chambers might contain records of the civilization that actually built the pyramids, including their true age, purpose, and the knowledge they preserved from even earlier times. Any of these possibilities would require fundamental revision of accepted historical timelines and archaeological theories. The discovery of advanced ancient technology or much older construction dates would invalidate decades of academic work and institutional investment. Sometimes the most important discoveries are the ones that powerful institutions work hardest to prevent. When evidence threatens established paradigms, expect systematic resistance regardless of public interest or scientific value. The Gantenbrink door mystery represents just one example of how crucial discoveries about pyramid construction have been systematically obstructed. But it's not the only hidden chamber that authorities refuse to investigate. In 2017, international scientists made an even more startling discovery, a massive void inside the Great Pyramid that's larger than any known chamber. Once again, requests for exploration have been denied, and the world's greatest ancient mystery remains deliberately unsolved. The Hidden Void, 2017's breakthrough discovery. The technology that sees through stone. November 2nd, 2017. The scientific journal Nature published what many considered the most significant archaeological discovery of the 21st century, the detection of a massive hidden void inside the Great Pyramid of Giza. This wasn't speculation or theory. It was hard scientific data obtained using cutting-edge technology that can literally see through solid stone without disturbing it. The discovery was made using muon tomography, a technique that detects cosmic ray particles called muons as they pass through different materials. Dense materials like stone block more muons than empty spaces, allowing scientists to create detailed three-dimensional maps of internal structures. Muon tomography is the same technique used to examine the internal structure of nuclear reactors, volcanic cores, and damaged buildings. It's proven, peer-reviewed science that produces results accurate enough for critical engineering decisions. The team that made this discovery included scientists from 3 countries: Japan, France, and Egypt, working under the Scan Pyramids project. This wasn't amateur investigation or fringe research. This was mainstream science using the most advanced, non-invasive techniques available. Sometimes the most important discoveries require waiting for technology to advance enough to reveal what was always there. Ancient secrets can remain hidden until modern science develops the tools to uncover them safely. The massive discovery above the Grand Gallery. What the muon tomography revealed defied all expectations and challenged every assumption about the Great Pyramid's internal structure. Located above the Grand Gallery, scientists detected an enormous empty space, approximately 100 feet long and 25 feet high, larger than any previously known chamber inside the pyramid. The hidden void has roughly the same volume as the King's Chamber, Queen's Chamber, and Grand Gallery combined. It's not a small architectural feature or symbolic space. It's a major structural component that has remained hidden for over 4,500 years. 3 independent detection methods all confirm the void's existence and approximate dimensions: muon tomography from multiple angles, thermal infrared scanning detecting temperature variations, and ground-penetrating radar confirming structural anomalies. When multiple advanced technologies independently confirm the same finding, you're looking at robust scientific evidence, not measurement error or wishful thinking. The void sits directly above the Grand Gallery, one of the most precisely constructed spaces in the entire pyramid. Its position suggests it was deliberately designed as part of the original architecture, not created by later structural damage or collapse. When different scientific techniques all point to the same conclusion, you can have confidence in the reliability of the results. Independent verification is the foundation of trustworthy science, the access problem that shouldn't exist. What's puzzling about this massive hidden chamber? There's no visible entrance to it from any of the pyramid's known passages or chambers. The void is completely isolated from all known internal passages. If it was meant to serve a functional purpose, whether ceremonial, storage, or construction-related, the builders would have needed some way to access it. Possible access methods include hidden passages that haven't been discovered yet, entrance systems that were sealed and concealed after construction, access methods that use techniques we don't understand, or the chamber served purposes that didn't require human access after completion. Detailed structural analysis reveals that the void appears to have been constructed with the same precision and planning as the pyramid's other major chambers. It's not an accidental space created by construction errors, it's an intentional architectural feature. Imagine discovering a massive room in the Empire State Building that doesn't appear on any blueprints and has no apparent entrance from any floor. You'd immediately want to understand its purpose and how people were supposed to use it. When ancient structures contain spaces that seem impossible to access using known methods, it suggests the builders had capabilities or techniques that we haven't identified yet. The international scientific response. The discovery of the hidden void generated immediate and intense interest from the international scientific community. Researchers worldwide recognize this as potentially the most important archaeological opportunity of our lifetime. Universities, museums, and research institutions from dozens of countries immediately began proposing methods to explore the newly discovered chamber. The proposals included micro-drilling techniques requiring holes smaller than a strand of hair, advanced fiber optic cameras capable of operating in complete darkness, robotic exploration systems designed for confined spaces, and non-destructive imaging techniques that could map the chamber's contents. Modern technology could explore the chamber without causing any significant damage to the pyramid structure. The investigation could be conducted with minimal visual impact and maximum scientific value. Leading archaeologists, engineers, and physicists worldwide agreed that exploring the hidden void represented an unprecedented opportunity to advance our understanding of ancient Egyptian civilization. Dr. Mehdi Tayoubi, president of the Heritage Innovation Preservation Institute, stated, "This discovery could be the most significant archaeological finding since the tomb of Tutankhamun. We have the technology to explore it safely and responsibly. When experts across multiple disciplines reach consensus about the importance and feasibility of research, institutional resistance to that research becomes increasingly difficult to justify on scientific grounds." The immediate shutdown pattern repeats. Despite overwhelming international interest and the availability of safe, non-destructive exploration methods, Egyptian authorities quickly moved to prevent any investigation of the newly discovered chamber. Within weeks of the discovery's publication, Egyptian authorities announced that no exploration of the hidden void would be permitted until proper protocols could be established and conservation concerns addressed. The muon tomography project that discovered the void had been officially approved and supported by Egyptian authorities. The same international team that made the discovery was suddenly denied permission to investigate what they had found. This is identical to what happened with the Gantenbrink door discovery 24 years earlier. Major discovery generates worldwide scientific interest. International research teams propose safe investigation methods. Egyptian authorities initially appear cooperative. Sudden shutdown of all research without clear technical justification. Indefinite delay with promises of future investigation that never materialize. The proposed exploration methods for the hidden void were less invasive than the muon tomography that discovered it. If authorities approved the detection technology, logical consistency would suggest approving equally safe exploration technology. When the same sequence of events repeats multiple times across different discoveries in different decades, you're probably looking at systematic policy rather than coincidental decisions. What the void's position reveals. The location of the hidden void above the Grand Gallery provides crucial clues about the pyramid's true purpose and the knowledge of its builders. The void sits at the pyramid's center of mass, positioned to have minimal impact on the structure's overall stability. This suggests sophisticated engineering knowledge about load distribution and structural mechanics. The void's dimensions and positioning suggest it was designed to work in conjunction with the Grand Gallery, not independently of it. The two spaces appear to form an integrated system whose purpose we don't yet understand. Structural engineers note that the void's location would be optimal for several theoretical purposes: acoustic resonance chamber working with the Grand Gallery's sound properties, mechanical system designed to amplify or modify forces within the pyramid, observatory or astronomical instrument housing that required specific positioning, or storage space for objects too valuable or dangerous to place in accessible chambers. Creating a void of this size in exactly this position would require planning and execution capabilities that exceed what conventional archaeology attributes to ancient Egyptian builders. When architectural features are placed with precision that serves specific engineering purposes, it indicates the builders understood principles that might be more advanced than we've assumed. The institutional resistance deepens. As international pressure for exploration of the hidden void has continued, Egyptian authorities have developed increasingly sophisticated methods of resistance that avoid direct confrontation with the scientific community. Rather than simply refusing exploration permits, authorities have created complex approval processes that require multiple agencies, extended review periods, and constantly changing requirements. Research teams report that permit applications are transferred between different departments, subjected to new requirements each time, and delayed indefinitely without clear resolution timelines. When pressed for specific objections to proposed exploration methods, authorities cite increasingly technical conservation concerns that seem designed to create insurmountable obstacles rather than address legitimate preservation issues. This bureaucratic resistance creates the appearance of legitimate review processes while effectively preventing any actual investigation. International researchers exhaust their funding and patience navigating administrative obstacles rather than conducting scientific work. When bureaucratic processes become more complex than the technical challenges they're supposed to address, the processes themselves may be designed to prevent rather than facilitate legitimate research. What we're not being allowed to discover. The hidden void represents our greatest opportunity to understand who really built the Great Pyramid and how they achieved such impossible precision. Yet this opportunity is being systematically denied to the global scientific community. Exploration of the chamber could reveal original construction tools and techniques that would prove or disprove conventional theories, astronomical instruments or calculations that would demonstrate the builder's true knowledge level, historical records or artifacts that would establish accurate construction dates, or technology or methods that would revolutionize our understanding of ancient capabilities. Any of these discoveries could fundamentally change our understanding of human history. Every year that passes, without investigation represents lost opportunities for scientific advancement. The techniques and technologies available for safe exploration continue to improve, making the arguments for delay increasingly invalid. When authorities prevent investigation of discoveries that could advance human knowledge significantly, consider whether protecting established paradigms has become more important to them than pursuing truth. The Hidden Void discovery of 2017 represents the most recent example of a disturbing pattern. Groundbreaking discoveries about the pyramids are consistently prevented from full investigation. But to understand why this pattern exists, we need to examine the person who has controlled Egyptian archaeology for decades and shaped what the world is allowed to learn about its greatest ancient mystery. The story of modern pyramid research cannot be told without understanding the role of one man whose decisions have determined which secrets remain buried and which truths never see the light of day. Zahi Hawass, gatekeeper of history, the man who controls Egypt's past. For over 3 decades, one man has wielded unprecedented control over Egyptian archaeology and determined what the world is allowed to learn about its greatest ancient mysteries. Dr. Zahi Hawass rose from humble beginnings as a tour guide to become the most powerful figure in Egyptian antiquities and perhaps the most controversial gatekeeper of archaeological knowledge in modern history. His influence matters so much because as Secretary General of Egypt's Supreme Council of Antiquities and later as Minister of Antiquities, Hawass controlled every excavation permit, every research project, and every discovery announcement in Egypt. No one could dig, explore, or publish findings about Egyptian archaeology without his approval. This level of centralized control over archaeological research is virtually unprecedented in the modern world. Most countries distribute archaeological authority among multiple institutions, universities, and government agencies to ensure balanced oversight and prevent any single individual from dominating scientific research. But in Egypt, Zahi Hawass became archaeology's ultimate authority, with the power to advance or destroy the careers of researchers worldwide. His decisions shaped not only what discoveries were made, but more importantly, which discoveries the public was allowed to learn about. When any single individual gains complete control over access to important historical evidence, scientific objectivity becomes subordinate to personal and political considerations. The rise to absolute power. Understanding how Hawass gained such extraordinary control over Egyptian archaeology reveals the systematic consolidation of power that enabled decades of research obstruction. Hawass began as a tour guide at the Giza Plateau in the 1960s, work that gave him intimate familiarity with the monuments but no formal archaeological training. His charismatic personality and media-friendly approach attracted attention from television producers and journalists looking for Egyptian experts willing to provide entertaining commentary. In the 1980s, Hawass obtained his PhD in Egyptology from the University of Pennsylvania. However, multiple sources suggest his dissertation research was heavily guided by advisors with specific theoretical commitments to conventional chronology and construction methods. What's significant about his academic background is that Hawass's doctoral training emphasized defending established archaeological narratives rather than questioning them. His early academic success came from supporting conventional theories, not challenging them with new evidence. Hawass's rise to power coincided with Egyptian government efforts to centralize control over the country's archaeological heritage. Tourism revenues from ancient sites were becoming increasingly important to Egypt's economy, creating incentives to present unified, marketable narratives rather than complex or controversial research findings. Unlike most archaeologists, Hawass actively courted media attention and developed a public persona as the Indiana Jones of Egyptology. This celebrity status gave him influence that extended far beyond academic circles and made him the public face of Egyptian archaeology worldwide. When scientific authority becomes linked to media, celebrity, and political convenience rather than research excellence, the pursuit of truth often becomes secondary to maintaining popular narratives. The pattern of research obstruction. Once Hawass gained control over Egyptian archaeology, a clear pattern emerged in how he handled research that challenged conventional explanations of pyramid construction and ancient Egyptian capabilities. Rather than engaging with alternative theories through open scientific debate, Hawass consistently used his administrative authority to prevent research that might challenge established narratives. Several documented cases of research obstruction stand out. The Gantenbrink door investigation from 1993 to present, despite worldwide scientific interest and National Geographic funding, Hawass effectively ended exploration of the sealed chambers, after the brief 2002 investigation revealed additional sealed doors. The Robert Bauval-Orion correlation follow-up. After Bauval published evidence linking pyramid alignment to 10,500 BC star positions, Hawass banned him from conducting further research in Egypt and publicly dismissed his findings without providing counter-evidence. The Graham Hancock research restrictions. Hancock, author of Fingerprints of the Gods, was denied research permits after proposing investigations that might support advanced ancient civilization theories. The John Anthony West geological studies. Despite West's geological evidence being supported by professional geologists, Hawass prevented follow-up studies that might confirm water erosion dating of the Sphinx. What these cases have in common is that in each instance, Hawass used administrative authority rather than scientific evidence to shut down research. He didn't refute the findings, he prevented the investigations that might confirm them. When authority figures consistently prevent, rather than engage with challenging research, they're often protecting established narratives rather than pursuing scientific truth. The academic intimidation campaign. Hawass's control extended beyond just denying research permits. He actively worked to damage the careers and reputations of researchers who challenged conventional Egyptian chronology. Hawass used his influence in academic circles to ensure that researchers who proposed alternative theories faced professional consequences that extended far beyond Egypt. The intimidation system worked in several ways. Researchers who challenged conventional narratives found their work excluded from major archaeological journals. Conference organizers were pressured to reject presentations of alternative theories. University departments were warned that hiring certain researchers might affect their access to Egyptian archaeological sites. Funding agencies received communications questioning the scientific validity of heterodox research proposals. Specific examples of career damage include Dr. Robert Schoch. Despite being a tenured geology professor at Boston University, Schoch faced systematic exclusion from Egyptological conferences and publications after his water erosion analysis challenged Sphinx dating. Independent researchers like West, Bauval, and Hancock found themselves effectively blacklisted from legitimate archaeological venues, forcing them to publish through alternative channels that were then dismissed as non-peer-reviewed. Graduate students and junior faculty learned that researching alternative theories about Egyptian monuments could damage their career prospects, creating a chilling effect that discouraged innovation in the field. When professional consequences are imposed for questioning established theories, rather than for poor research quality, scientific progress becomes subordinate to career preservation. The media manipulation machine. Hawass understood that controlling public perception was as important as controlling academic research. He developed sophisticated media strategies that shaped how pyramid mysteries were presented to the general public. Hawass appeared regularly on History Channel, National Geographic, and Discovery Channel programs, always presenting conventional explanations with absolute certainty while dismissing alternative theories as nonsense without detailed refutation. The media manipulation worked through television producers needing Egyptian government cooperation to film at archaeological sites. Hawass used this leverage to ensure that documentaries presented only approved narratives, regardless of what evidence might suggest. Rather than engaging with specific evidence, Hawass developed a strategy of dismissing alternative theories with brief, authoritative-sounding statements that television audiences would accept without further investigation. Examples of media manipulation include statements like, "The pyramids were built by Egyptians, period. Anyone who says otherwise is selling books." These alternative theories have no scientific basis. Real archaeologists know how the pyramids were built. I am the authority on Egyptian archaeology. These other people are not qualified to speak. Television audiences typically don't have the background knowledge to evaluate archaeological claims critically. Hawass's authoritative presentation style could convince viewers that complex mysteries had simple solutions, even when the evidence suggested otherwise. When television networks attempted to produce programs exploring alternative theories, they often found their access to Egyptian sites restricted unless they included substantial conventional narrative segments featuring Hawass. When authority figures use media access as leverage to control the presentation of scientific information, public understanding becomes shaped by political considerations rather than evidence evaluation. The economics of archaeological control. Understanding Hawas's motivations requires examining the economic incentives that shaped Egyptian archaeological policy during his tenure. Egypt's archaeological sites generate hundreds of millions of dollars annually in tourism revenue. This creates powerful incentives to present simple, inspiring narratives that attract visitors rather than complex mysteries that might confuse or discourage tourism. Economic pressure influenced research priorities in that discoveries that supported conventional narratives about Egyptian achievement received extensive promotion and media coverage. Discoveries that raised questions about conventional chronology or builders were quietly minimized or suppressed. Major archaeological projects in Egypt require substantial international funding from universities, museums, and research institutions. Hawas's approval was essential for accessing these funds, giving him leverage over the global archaeological community. Hawas's celebrity status generated significant personal income through book sales, television appearances, and speaking engagements. Maintaining his role as the authority on Egyptian archaeology required defending the conventional narratives that established his expertise. Egyptian academic and government institutions had invested decades of credibility in conventional explanations of pyramid construction. Acknowledging that these explanations might be wrong would require admitting institutional error on a massive scale. When substantial financial interests become tied to maintaining specific historical narratives, scientific objectivity often becomes subordinate to economic considerations. The international academic complicity. Hawas's control over Egyptian archaeology was enabled by the complicity of international academic institutions that prioritized access over scientific integrity. Universities and museums worldwide wanted access to Egyptian archaeological sites for their research and educational programs. This created a system where international institutions avoided challenging Hawas's authority in order to maintain their Egyptian partnerships. Academic complicity worked through rather than defending researchers who challenged conventional narratives. International institutions often distanced themselves from controversial figures to preserve their relationships with Egyptian authorities. Academic journals with editorial boards that included Egyptian archaeology specialists often found their review processes influenced by concerns about maintaining access to Egyptian research sites. Specific examples of institutional complicity include universities discouraging faculty from pursuing research that might displease Egyptian authorities. Museums organized exhibitions that presented only conventional narratives about Egyptian monuments. Professional archaeological societies avoided conference sessions that might challenge established timelines. Major archaeological organizations worldwide failed to speak out against the systematic obstruction of legitimate research, instead treating it as an internal Egyptian matter beyond their concern. When scientific institutions prioritize institutional interests over scientific integrity, they become participants in the suppression of legitimate research rather than defenders of academic freedom. The legacy of suppressed discovery. By the time Hawass stepped down from his official positions in 2011, he had shaped Egyptian archaeology in ways that continue to obstruct legitimate research today. Hawass established precedents and policies that treated challenging research as threats to be managed rather than scientific questions to be investigated. These institutional attitudes persist even after his departure from official positions. The archaeologists who rose to prominence under Hawass's mentorship were selected and promoted based on their willingness to defend conventional narratives rather than their commitment to open scientific inquiry. This means that even with new leadership, Egyptian archaeological institutions continue to operate according to the precedents Hawass established. Research that might challenge conventional timelines or builders still faces systematic obstruction. Hawass's policies created lasting damage to Egypt's reputation within the international scientific community. Many researchers now avoid proposing projects that might challenge established narratives, knowing that such research is unlikely to receive approval. Decades of suppressed research represent lost opportunities to advance human understanding of our ancient past. Technologies for safe, non-destructive investigation have advanced dramatically, but access to crucial archaeological sites remains restricted. When suppressive policies become embedded in institutional culture, they continue to obstruct legitimate research long after the individuals who created them are no longer in power. The pattern of research obstruction that Hawass established reveals something deeply troubling about how archaeological knowledge is controlled and distributed. But understanding why this system exists requires examining the broader context of institutional investment in conventional historical narratives. The resistance to pyramid research isn't just about protecting one man's career or reputation. It's about preserving an entire academic and cultural framework that depends on maintaining specific beliefs about when and how human civilization developed. The academic conspiracy, the system of cover-up, the hidden framework of historical control. The systematic suppression of pyramid research reveals something far more significant than individual career protection or institutional pride. It exposes a coordinated effort to maintain historical narratives that serve specific cultural, religious, and political purposes, regardless of what physical evidence might suggest. We need to understand that the resistance to alternative theories about pyramid construction isn't random or coincidental. It's part of a broader pattern of historical control that determines which discoveries are promoted, which are suppressed, and which questions are never allowed to be asked. This system operates across multiple institutions, countries, and academic disciplines, suggesting coordination that goes far beyond any single archaeologist or organization. The biblical timeline constraint. One of the most revealing insights into this system comes from understanding how archaeological chronology has been shaped by religious considerations rather than purely scientific evidence. As noted by Egyptian commentators who live near the pyramids, modern archaeological timelines are deliberately constructed to avoid contradicting biblical narratives about human history. Academic archaeology maintains an informal but rigid limit. No major civilization is allowed to be older than approximately 7,000 years. When scientific timelines align suspiciously well with religious texts rather than physical evidence, consider whether the science is being shaped by non-scientific considerations. The Church-Science Alliance. The relationship between religious institutions and archaeological establishments reveals how theological concerns continue to influence supposedly secular scientific research. During the 19th and early 20th centuries, when modern archaeology was developing its foundational theories, Christian institutions wielded enormous influence over educational and research institutions. Archaeological interpretations that contradicted biblical chronology faced institutional resistance that could destroy careers. Rather than following evidence wherever it led, early archaeologists learned to frame their discoveries within chronological frameworks that didn't challenge religious narratives about human history. While direct religious control over archaeology has diminished, the institutional frameworks established during the church-dominated era continue to shape research priorities and acceptable conclusions. Specific examples of religious influence include: archaeological dating methods are rarely applied to discoveries that might push civilization back beyond biblical timelines. Research proposals that might challenge the uniqueness of biblical flood narratives face funding difficulties. Academic positions in archaeology often require implicit agreement with chronological frameworks that accommodate religious sensibilities. Academic journals in archaeology and ancient history often have editorial boards that include scholars with explicit or implicit commitments to maintaining chronological frameworks compatible with religious texts. When supposedly secular scientific fields maintain conclusions that suspiciously align with religious requirements, examine whether theological considerations are shaping supposedly objective research. The Göbekli Tepe cover-up. The treatment of Göbekli Tepe in Turkey provides a perfect example of how the academic establishment handles discoveries that threaten conventional chronological frameworks. Göbekli Tepe is an archaeological site containing sophisticated stone temples that date to approximately 11,600 years ago, nearly 7,000 years before Stonehenge, and 6,000 years before the supposed invention of agriculture. According to established archaeological theory, hunter-gatherer societies couldn't have built sophisticated religious complexes. Complex architecture supposedly required agricultural surpluses, settled populations, and social hierarchies that didn't exist in the Neolithic period. Rather than revising theories about early human capabilities, authorities have worked to limit public access to information about Göbekli Tepe and minimize its implications for understanding ancient civilization. After initial excavations confirmed the site's extreme age and sophistication, Turkish authorities constructed a modern building that literally covers most of the archaeological remains. This structure limits access and prevents independent researchers from conducting detailed studies. Despite representing perhaps the most important archaeological discovery of the past century, Göbekli Tepe receives minimal coverage in mainstream archaeological publications and educational materials. When Göbekli Tepe is discussed in academic contexts, it's typically presented as an anomaly or exception rather than evidence that requires fundamental revision of theories about early human civilization. When discoveries threaten fundamental theoretical frameworks, expect institutional efforts to physically and intellectually contain the implications rather than embrace the evidence. The Olmec dating scandal. The treatment of researchers who challenge conventional dating provides another clear example of how the academic establishment suppresses evidence that threatens established chronological frameworks. The colossal stone heads of the Olmec civilization in Mexico display sophisticated carving techniques and apparent African facial features that challenge conventional theories about pre-Columbian American civilizations. In the 1990s, a prominent scientist specializing in archaeological dating concluded that the Olmec heads, dated to approximately 10,000 BC, far older than conventional theories allow for advanced civilization in the Americas. Despite her established reputation and expertise in archaeological dating methods, she was systematically excluded from academic conferences, denied research funding, and effectively forced out of her field for insisting on dates that contradicted established chronology. This example reveals the standard method for dealing with researchers who present inconvenient evidence. 1. Exclude them from peer review processes. 2. Deny them access to additional samples for confirmation studies. 3. Prevent publication of their findings in mainstream journals. 4. Damage their professional reputation through informal networks. 5. Cut off funding for continued research. The treatment of the Olmec dating researcher sent a clear message to other scientists. Challenging chronological frameworks threatens career survival, regardless of evidence quality. When researchers face professional destruction for presenting unwelcome evidence rather than for poor methodology, the scientific establishment is protecting paradigms rather than pursuing truth. The funding control system. Understanding how research funding is controlled reveals the mechanisms that ensure conformity to established narratives in archaeology and ancient history. Major research funding in archaeology comes from government agencies, private foundations, and university systems. The peer review process that determines funding allocation is dominated by established academics with investments in maintaining conventional theories. Proposals that might challenge fundamental chronological or theoretical frameworks are systematically rejected, not for methodological flaws, but for pursuing unproductive research directions. Funding agencies prefer projects that will produce publishable results within established theoretical frameworks. Research that might fail to confirm conventional theories is seen as risky and unlikely to receive support. Specific examples of funding manipulation include proposals to conduct detailed geological dating of the Sphinx have been rejected multiple times despite technical feasibility. Research into advanced ancient technologies is consistently underfunded compared to studies that confirm primitive tool use. International collaborations that might challenge conventional timelines face bureaucratic obstacles that effectively prevent implementation. Young researchers quickly learn that funding success requires proposing projects that confirm rather than challenge established theories. This creates a self-perpetuating system where only conformist research receives institutional support. When resource allocation systematically favors research that confirms established theories while excluding studies that might challenge them, institutional bias shapes scientific progress more than evidence quality. The publication gatekeeping. The control over which research findings reach the academic community and general public reveals perhaps the most effective mechanism for suppressing inconvenient discoveries. Academic journals use peer review processes that can easily exclude research challenging established paradigms. Reviewers with investments in conventional theories can reject papers by claiming methodological flaws or insufficient evidence, regardless of actual research quality. Papers challenging conventional chronology or construction methods face review by scholars who have built careers defending the theories being challenged. This creates obvious conflicts of interest that systematically favor conventional narratives. The most prestigious archaeological journals maintain editorial policies that effectively exclude heterodox research. This creates a credibility gap, where challenging theories can only be published in lower-tier venues, which are then dismissed for not appearing in proper academic publications. Specific examples of publication bias include Robert Bauval's Orion correlation research was rejected by major archaeology journals despite mathematical verification. Geological evidence for Sphinx water erosion has been excluded from Egyptology publications while being accepted in geology journals. Research supporting advanced ancient technologies consistently faces higher evidentiary standards than studies confirming primitive methods. Established researchers preferentially cite work that supports conventional theories while ignoring or dismissing research that challenges them. This creates artificial consensus in the published literature that doesn't reflect the actual strength of evidence. When academic publishing systematically excludes research that challenges established theories, the appearance of scientific consensus can be manufactured rather than genuinely earned through evidence evaluation. The international coordination. The consistency of research suppression across different countries and institutions suggests coordination that transcends national boundaries and individual careers. The same patterns of research obstruction appear in archaeological establishments worldwide. Whether in Egypt, Turkey, Mexico, or Peru, discoveries that challenge conventional chronology face similar institutional resistance. When researchers are excluded from sites in one country for challenging conventional theories, they often find themselves excluded from related sites in other countries as well, suggesting communication between international archaeological establishments. Major international conferences in archaeology and ancient history consistently exclude presentations that challenge fundamental chronological frameworks, regardless of research quality or evidence strength. International organizations like UNESCO, which oversee World Heritage sites, often defer to local archaeological authorities who have investments in maintaining conventional narratives. This creates a global system that reinforces local suppression efforts. When independent researchers gain access to important sites and begin producing challenging evidence, diplomatic pressure is often applied to home country institutions to discourage continued research. When the same suppression techniques appear consistently across different countries and cultures, you're probably looking at coordinated policy rather than independent institutional decisions. The economic incentives behind historical control. Understanding the economic forces that support historical narrative control reveals why institutional resistance to alternative theories is so persistent and well-funded. Countries with major archaeological sites generate billions of dollars annually from tourism based on conventional historical narratives. Changing these narratives could disrupt established tourism markets and require expensive reinterpretation of sites and museums. Academic and popular publishers have invested enormous resources in books, textbooks, and educational materials based on conventional chronology. Fundamental revisions would require reprinting and updating vast quantities of material. Universities, museums, and research institutions have built reputations based on supporting specific theoretical frameworks. Acknowledging fundamental errors would damage institutional credibility and potentially affect funding and enrollment. Thousands of academic careers are built on expertise in conventional interpretations of ancient history. Major revisions would render much of this expertise obsolete and threaten job security across the archaeological establishment. When changing historical narratives would threaten substantial economic interests, expect institutional resistance that's motivated by financial considerations rather than scientific integrity. The systematic suppression of pyramid research reveals an academic establishment that has prioritized protecting established narratives over pursuing truth. But understanding why this system exists requires examining the specific historical and cultural forces that created the need for such extensive control over archaeological knowledge. The next phase of our investigation explores how this system of academic control connects to broader efforts to maintain specific beliefs about human capabilities and the development of civilization. Napoleon's Secret, the discovery that was hidden. The Egyptian expedition that changed everything. July 1798. Napoleon Bonaparte arrived in Egypt with more than just military conquest in mind. Accompanying his army were 167 scholars, scientists, and artists tasked with conducting the most comprehensive study of ancient Egyptian civilization ever attempted. What they discovered would shake the foundations of European understanding about ancient history and create conflicts between science and religious authority that continue to shape archaeological research today. Napoleon's expedition documented thousands of monuments, hieroglyphic inscriptions, and architectural achievements that exceeded European expectations about ancient capabilities. The scholars found evidence of mathematical, astronomical, and engineering knowledge that challenged assumptions about primitive ancient civilizations. What made their findings so revolutionary was this: the expedition's measurements and documentation revealed that ancient Egyptian achievements surpassed many contemporary European capabilities in precision, scale, and sophistication. But according to local Egyptian sources who live near the pyramids, not all of these discoveries were ever shared with the public. The most challenging findings were quietly classified and hidden from view, establishing a pattern of selective disclosure that continues today. When major discoveries challenge established religious and cultural narratives, powerful institutions often work to control which information reaches the public, regardless of its scientific importance. The Champollion Dilemma. Jean-François Champollion, the French scholar credited with deciphering Egyptian hieroglyphs, found himself at the center of a conflict between scientific discovery and religious orthodoxy that would shape how ancient Egyptian achievements were presented to the European public. Champollion's breakthrough in reading hieroglyphic texts should have been celebrated as one of history's greatest intellectual achievements. For the first time in over 1,000 years, Europeans could read the actual words of ancient Egyptian civilization. As Champollion translated more texts, he discovered references to historical events, technological capabilities, and astronomical knowledge that contradicted biblical chronology and European assumptions about ancient civilizations. What created the crisis was this: the hieroglyphic texts described engineering achievements, mathematical calculations, and historical timelines that were incompatible with the biblical account of human history that dominated European thought. Rather than celebrating these discoveries, religious authorities in France began pressuring the expedition's scholars to suppress findings that might undermine biblical narratives about ancient history and human development. Champollion and other expedition members found themselves forced to choose between scientific integrity and career survival. Those who insisted on publishing challenging discoveries faced institutional resistance that could destroy their professional futures. When scientific discoveries threaten established religious narratives, individual researchers often face impossible choices between truth and professional survival. The Hidden Documentation Project. According to Egyptian sources familiar with the expedition's work, Napoleon's scholars created two sets of documentation: public reports that avoided controversial conclusions, and classified records that contained their most significant discoveries. The published results of Napoleon's expedition, including the famous Description de l'Égypte, carefully avoided conclusions that might challenge biblical chronology or suggest advanced ancient technologies. Local Egyptian historians claim that the expedition's most important findings were documented in classified reports that were never published and remain hidden in French archives to this day. These hidden records supposedly contain precise measurements revealing mathematical relationships in pyramid construction that exceed modern understanding, astronomical calculations embedded in monument alignments that demonstrate advanced ancient knowledge, references to historical events and timelines that contradict accepted chronology, and evidence of construction techniques that would require technologies not officially invented until centuries later. Rather than risk public controversy over discoveries that might undermine religious authority, French institutions allegedly developed a policy of selective disclosure that promoted discoveries supporting conventional narratives while suppressing challenging evidence. Researchers who have attempted to access Napoleon's complete expedition records report bureaucratic obstacles and restricted access that prevents comprehensive study of the materials. When institutions create classified records of scientific discoveries, consider whether public education is being subordinated to protecting established beliefs from challenging evidence. The pattern of selective history. The treatment of Napoleon's Egyptian discoveries established a template for how challenging archaeological evidence has been handled ever since. Promote discoveries that confirm established narratives while suppressing those that raise inconvenient questions. Discoveries that demonstrated ancient Egyptian artistic achievement, religious devotion, and cultural sophistication received extensive publicity and scholarly attention. Evidence of advanced engineering, mathematical knowledge, or historical timelines that challenged conventional chronology was quietly minimized or excluded from public discourse. By carefully choosing which discoveries to emphasize and which to ignore, institutions can create public understanding that supports specific narratives regardless of what the complete evidence might suggest. Modern examples of selective promotion include King Tutankhamun's treasures receive massive media attention while evidence of advanced ancient technologies remains obscure. Pyramid construction theories that emphasize primitive methods get textbook coverage, while precision engineering evidence is marginalized. Archaeological discoveries that fit conventional timelines receive museum exhibitions, while challenging evidence remains in storage. Generations of students learn about ancient Egypt through carefully curated evidence that supports specific conclusions about ancient capabilities and historical development. When only certain types of discoveries receive public attention while others remain hidden, public understanding is being shaped by institutional agendas rather than comprehensive evidence evaluation. The French Archive Mystery. The question of what remains hidden in French archives from Napoleon's expedition continues to intrigue researchers who believe crucial evidence about ancient Egyptian civilization has been deliberately concealed. Multiple researchers have reported difficulties accessing complete records from Napoleon's Egyptian expedition. Requests for archival materials often face bureaucratic delays, restricted access, or claims that materials are unavailable for research. Comparison of expedition documentation with published materials reveals significant gaps, suggesting that substantial findings were never included in public reports. Archive researchers have discovered this. Cross-referencing expedition member letters and journals reveals references to discoveries and measurements that don't appear in official publications, suggesting systematic exclusion of certain types of evidence. Advanced imaging and measurement technologies could now verify or refute the expedition's suppressed findings, but access to the original documentation remains restricted. Similar archive access problems appear in other countries with major archaeological discoveries, suggesting coordinated policies for controlling access to potentially challenging historical evidence. When historical documents remain inaccessible to researchers despite their obvious scientific importance, institutional control over information often serves political rather than scholarly purposes. The religious-scientific conflict continues. The conflict between scientific discovery and religious orthodoxy that began with Napoleon's expedition continues to influence how archaeological evidence is interpreted and presented today. While direct religious control over archaeological research has diminished, the institutional frameworks established during periods of church dominance continue to shape research priorities and acceptable conclusions. Academic archaeology still maintains informal limits on how old advanced civilizations can be, limits that coincidentally align with biblical chronology rather than being based on purely scientific considerations. Religious influence persists in this way. Research proposals, funding decisions, and publication policies often reflect unstated assumptions about acceptable timelines and human capabilities that derive from religious rather than scientific considerations. Universities, museums, and research institutions established during periods of strong religious influence often maintain policies and theoretical commitments that serve theological rather than scientific purposes. The spread of European educational and research institutions worldwide has globalized chronological frameworks that were originally designed to accommodate Christian theology rather than follow evidence wherever it might lead. When supposedly secular scientific institutions maintain conclusions that suspiciously accommodate religious requirements, examine whether theological considerations continue to shape supposedly objective research. What Napoleon's scholars really found. Based on available evidence and local Egyptian knowledge, Napoleon's expedition likely discovered proof that ancient Egyptian civilization possessed capabilities far more advanced than European scholars were prepared to acknowledge. Precise measurements of pyramid construction probably revealed mathematical relationships and geometric principles that demonstrated knowledge supposedly not developed until much later in human history. Monument alignments and inscriptions likely contained astronomical calculations that proved ancient Egyptians possessed sophisticated knowledge of celestial mechanics and precession cycles. Documentation of construction techniques probably revealed methods for moving massive stones and achieving precision that exceeded contemporary European capabilities. Hieroglyphic texts likely contained chronological references that contradicted biblical timelines and suggested much older development of advanced civilization. Rather than risk undermining European religious and cultural superiority narratives, institutional authorities chose to suppress evidence that might force fundamental revisions of accepted history. When evidence challenges foundational cultural and religious beliefs, institutions often choose to protect established narratives rather than follow scientific evidence to uncomfortable conclusions. The systematic suppression of discoveries that began with Napoleon's expedition reveals how powerful institutions have controlled historical knowledge for over 2 centuries. But understanding the full scope of this suppression requires examining how these policies have shaped our understanding of ancient civilizations worldwide. The same forces that suppressed Napoleon's Egyptian discoveries continue to influence archaeological research today, maintaining narratives about human development that may be fundamentally incorrect. The antediluvian civilization, evidence before the flood. The Great Forgetting. Across virtually every culture on Earth, ancient texts preserve memories of a time before recorded history when humanity possessed advanced knowledge and capabilities that were lost in a global catastrophe. These aren't isolated myths. They're consistent accounts from civilizations separated by thousands of miles and centuries of time, all describing the same pattern: advanced civilization, global disaster, and humanity's struggle to rebuild from primitive conditions. The universal flood narrative. Over 200 cultures worldwide preserve detailed accounts of a great flood that destroyed an earlier civilization. These stories appear in Mesopotamian texts, the Epic of Gilgamesh, Atrahasis, biblical accounts, Noah's flood, Hindu scriptures, Matsya Purana, Native American traditions across dozens of tribes, Australian Aboriginal Dreamtime stories, African tribal histories, Chinese classical texts. The consistency of details across cultures that had no contact with each other suggests these stories preserve actual historical memories rather than symbolic mythology. The advanced antediluvian civilization. These flood accounts consistently describe the destroyed civilization as possessing knowledge and capabilities that exceeded those of the storyteller's own time. The ancient texts don't just describe primitive people who drowned, they describe advanced societies with sophisticated technology, astronomical knowledge, and architectural achievements. Civilizational collapse and recovery follows predictable patterns where knowledge preservation determines how quickly and completely advanced capabilities can be reestablished. The Younger Dryas impact evidence. Modern science has now confirmed that a global catastrophe occurred exactly when ancient flood narratives claim it did, approximately 12,800 years ago at the beginning of the Younger Dryas period. The cosmic impact discovery. In the early 2000s, researchers led by Richard Firestone and Graham Hancock identified evidence of multiple comet impacts that struck Earth at the end of the last ice age. This wasn't theoretical speculation. It was physical evidence found in geological layers worldwide. The impact evidence shows microscopic diamonds formed by extreme pressure and heat, spherules of melted rock created by impact explosions, platinum and iridium concentrations consistent with extraterrestrial objects, nanodiamonds and carbon spherules distributed across multiple continents, evidence of massive fires and atmospheric disruption. The global scope. This impact evidence appears in geological layers across North America, Europe, Asia, and South America, proving that the catastrophe affected the entire planet simultaneously. The Younger Dryas climate disruption. The impacts triggered a 1,300-year period of global cooling that eliminated most large mammals in North America, disrupted ecosystems worldwide, and forced dramatic changes in human settlement patterns. The geological evidence for cosmic impacts dates to approximately 12,800 years ago exactly matching the timeline described in ancient flood narratives from cultures worldwide. When geological science confirms the timing and global scope of catastrophes described in ancient texts, those texts should be taken seriously as historical documents rather than dismissed as mythology. The archaeological evidence of lost civilization. While mainstream archaeology maintains that no advanced civilizations existed before approximately 5,000 years ago, mounting evidence suggests that sophisticated societies were operating at the end of the Ice Age and were destroyed in the Younger Dryas catastrophe. Göbekli Tepe's revolutionary timeline. The temple complex at Göbekli Tepe, in Turkey, dates to 11,600 years ago, nearly 7,000 years before Stonehenge, and 6,000 years before the supposed invention of agriculture. According to conventional archaeological theory, hunter-gatherer societies couldn't organize the labor, develop the skills, or maintain the social structures necessary to build sophisticated religious complexes. Yet Göbekli Tepe contains massive stone pillars, weighing up to 20 tons each, sophisticated carved reliefs depicting animals and symbols, complex architectural planning requiring advanced engineering, evidence of coordinated construction by large numbers of skilled workers, the deliberate burial mystery. Around 10,000 years ago, Göbekli Tepe was deliberately buried under tons of earth and abandoned. This wasn't natural erosion or accidental coverage. It was intentional concealment that preserved the site for modern discovery. Global megalithic construction. Similar sophisticated stone construction appears worldwide during the same time period. Gunung Padang in Indonesia, potentially 20,000 plus years old. Nan Madol in Micronesia, sophisticated engineering in Pacific isolation. Ancient stone structures in Peru, showing identical precision techniques. Megalithic sites across Europe demonstrating advanced astronomical knowledge. When sophisticated construction techniques appear simultaneously across continents during periods when such capabilities supposedly didn't exist, our timeline for human technological development is probably wrong. The knowledge preservation systems. Ancient texts from multiple cultures describe sophisticated systems designed to preserve crucial knowledge through catastrophic periods. Systems that suggest the antediluvian civilization anticipated its destruction and took measures to ensure critical information would survive. The Egyptian preservation tradition. Ancient Egyptian texts describe the followers of Horus, survivors of an earlier civilization who preserved knowledge through the flood catastrophe and transmitted it to later Egyptian dynasties. Egyptian sources tell us about knowledge preservation. Sacred texts were encoded in stone monuments designed to survive catastrophes. Astronomical knowledge was embedded in architectural alignments that couldn't be destroyed. Mathematical principles were incorporated into monument proportions to preserve precise calculations. Religious traditions maintained oral transmission of technical knowledge across generations. The Mesopotamian king lists. Sumerian texts describe kings who ruled for thousands of years before the flood, followed by much shorter reigns afterward. This pattern suggests the preservation of knowledge about earlier advanced civilizations through oral tradition. The Hindu cycle cosmology. Sanskrit texts describe recurring cycles of civilization and destruction, with knowledge being preserved by survivors who re-establish civilization after each catastrophe. The biblical antediluvian accounts. The Book of Enoch and other texts describe the Watchers, advanced beings who taught humanity, metallurgy, astronomy, mathematics, and other sophisticated knowledge before the flood. When multiple ancient cultures describe identical systems for preserving knowledge through catastrophes, they're probably recording actual historical strategies rather than creating fictional accounts. The technology transfer evidence. The sudden appearance of advanced capabilities in post-flood civilizations suggests that sophisticated knowledge was indeed preserved and transmitted by survivors of the antediluvian catastrophe. The sudden emergence pattern. Rather than showing gradual development over millennia, advanced civilizations appear in the archaeological record almost fully formed. Egyptian civilization emerges with sophisticated hieroglyphic writing, advanced mathematics, and precision engineering. Sumerian civilization appears with complex agriculture, urban planning, and astronomical knowledge. Indus Valley civilization develops advanced water management and urban design. This pattern suggests these civilizations didn't develop their capabilities from scratch. They inherited knowledge from earlier sources. The astronomical knowledge transfer. Post-flood civilizations worldwide demonstrate understanding of precession cycles, eclipse prediction, and stellar movements that require centuries of careful observation to develop. The mathematical inheritance. Complex mathematical concepts appear in early civilizations without evidence of the experimentation and development that such knowledge typically requires. The engineering capabilities. Post-flood civilizations demonstrate construction techniques and engineering principles that seem to exceed their supposed technological development level. When advanced knowledge appears in civilizations without evidence of gradual development, it probably represents inheritance from earlier sources rather than independent invention. The giants and advanced beings evidence. Ancient texts worldwide describe the antediluvian civilization as including beings of extraordinary size and capabilities, descriptions that were once dismissed as mythology, but are now being reconsidered in light of archaeological discoveries. The biblical Nephilim accounts. Hebrew texts describe giants who existed before the flood, possessing advanced knowledge and capabilities that they taught to humanity. The Book of Enoch details. This ancient text provides extensive descriptions of the Watchers, advanced beings who taught humans metallurgy, astronomy, mathematics, and other sophisticated technologies. The global giant traditions. Cultures worldwide preserve accounts of giants who existed in ancient times. Native American traditions describe tall beings with advanced knowledge. European folklore preserves memories of giant builders of megalithic monuments. Pacific Island cultures describe giant navigators and builders. South American traditions include accounts of giant civilizers. The archaeological evidence. Discovery of unusually large human remains and artifacts suggests that some giant accounts might preserve actual historical memories. Elongated skulls found worldwide showing non-human characteristics. Oversized tools and weapons requiring extraordinary strength to use. Megalithic construction showing capabilities that exceed normal human limits. The antediluvian civilization may have included beings with capabilities that exceeded those of normal humans, explaining the advanced achievements that seem impossible for primitive societies. When consistent accounts of extraordinary beings appear across diverse cultures, they may preserve memories of actual historical populations rather than fictional creations. The cataclysm recovery process. Understanding how civilization recovered from the Younger Dryas catastrophe reveals how knowledge was preserved and transmitted to post-flood societies. The survivor population. Geological evidence suggests that the cosmic impacts eliminated most large mammals and dramatically reduced human populations worldwide. The survivors would have faced extreme challenges in maintaining technological knowledge and social organization. The knowledge refugia. Certain geographic regions, particularly high-altitude areas and locations protected by geographical features, provided refuge where survivors could preserve crucial knowledge through the catastrophic period. The transmission methods. Survivors developed multiple strategies for preserving and transmitting knowledge. Oral traditions maintained through religious and cultural practices. Stone monuments encoding astronomical and mathematical information. Symbolic systems preserving technical knowledge in mythological narratives. Selective breeding and training programs maintaining specialized skills. The gradual reemergence. As climatic conditions stabilized after the Younger Dryas, survivor populations gradually re-established civilization using preserved knowledge combined with new adaptations to changed environmental conditions. The recovery process explains the sudden appearance of advanced capabilities in post-flood civilizations results from the combination of preserved antediluvian knowledge with new innovations developed during the recovery period. The Egyptian inheritance. The evidence we've examined suggests that ancient Egyptian civilization, including the builders of the pyramids, represents the inheritors and preservers of antediluvian knowledge rather than the original developers of advanced capabilities. The sudden sophistication. Egyptian civilization appears in the archaeological record already possessing advanced mathematical knowledge including pi and the golden ratio, sophisticated astronomical understanding including precession cycles, precision engineering capabilities that modern technology struggles to replicate. complex organizational systems for managing massive construction projects, the lack of development evidence. Despite extensive archaeological investigation, researchers have found little evidence of the gradual development process that such sophisticated capabilities should require. The preservation mission. Egyptian texts and traditions suggest that maintaining and preserving ancient knowledge was a central mission of their civilization, explaining their focus on creating permanent monuments that could survive future catastrophes. The inheritance model explains the impossible precision and advanced knowledge demonstrated in pyramid construction, represents the application of antediluvian technology by a civilization dedicated to preserving that knowledge for future generations. The time capsule function. The pyramids may have been designed not just as tombs or temples, but as technological and knowledge repositories intended to preserve crucial information through future catastrophic periods. The hidden chamber's purpose. The sealed chambers and hidden voids we've discovered might contain examples of antediluvian technology, knowledge systems, or historical records that would prove the inheritance theory. When civilizations demonstrate capabilities that exceed their apparent technological development level, they may be preserving and applying knowledge inherited from earlier advanced sources. The evidence for an antediluvian civilization that possessed advanced technology and knowledge provides a framework for understanding the pyramid mysteries we've explored. If the builders inherited, rather than developed, their sophisticated capabilities, it explains the precision, astronomical knowledge, and engineering achievements that seem impossible for their supposed time period. But this raises an even more important question. If ancient texts and geological evidence both point to the existence of advanced pre-flood civilizations, why does mainstream archaeology continue to insist that no such societies ever existed? The answer requires examining how this evidence connects to modern discoveries of advanced ancient technologies that challenge our fundamental assumptions about human technological development. When identical historical memories appear independently across diverse cultures worldwide, they likely preserve actual events rather than coincidental storytelling patterns. Advanced ancient technology, the lost knowledge, the technology that shouldn't exist. Hidden in museums, private collections, and archaeological sites around the world are artifacts that challenge everything we've been taught about ancient human capabilities. These aren't crude stone tools or primitive pottery. They're sophisticated devices that demonstrate engineering principles and manufacturing techniques that supposedly weren't developed until the modern industrial age. When archaeological discoveries don't fit established timelines for technological development, they typically disappear from public view. Museums place them in storage, academic papers avoid discussing them, and textbooks pretend they don't exist. If ancient civilizations possessed advanced technologies that we don't recognize or understand, it would explain the impossible precision and massive scale of pyramid engineering that seems beyond the capabilities of copper tools and rope. Rather than showing gradual technological development over thousands of years, the archaeological record reveals sophisticated capabilities appearing suddenly in multiple civilizations, suggesting inheritance from earlier advanced sources. When physical artifacts demonstrate capabilities that exceed their supposed time period, they probably represent evidence of more advanced ancient civilizations rather than anomalous accidents. The Baghdad battery and ancient electricity. In 1936, archaeologists working near Baghdad discovered clay jars containing copper cylinders and iron rods that functioned as electrochemical batteries. These devices, dating to approximately 250 BC, demonstrate understanding of electrical principles that supposedly weren't developed until the 18th century. When filled with an acidic solution, these ancient devices generate approximately 1.1 volts of electricity, sufficient for electroplating metals or powering small electrical devices. The Baghdad batteries weren't isolated anomalies. Similar devices have been found in Egypt, suggesting that electrical technology was known and used in ancient civilizations. Ancient artifacts from multiple civilizations show evidence of electroplating, using electrical current to coat objects with thin layers of precious metals. This process requires sustained electrical power and sophisticated understanding of electrochemical principles. Engineer Christopher Dunn has proposed that the Great Pyramid functioned as a power plant, using the pyramid's internal structure to generate electrical current through piezoelectric effects in the granite stones. When subjected to mechanical stress, granite generates electrical charge through the piezoelectric effect. The pyramid's internal chambers and passages could have been designed to amplify and harness this electrical generation. The evidence for pyramid electrical function includes several key points. The pyramid contains no soot marks from torches, suggesting alternative lighting. The king's chamber is constructed entirely of granite, which has strong piezoelectric properties. The internal passages show evidence of liquid flow that could have been electrolyte solutions. The pyramid's location sits on underground water flows that could complete electrical circuits. When multiple civilizations demonstrate understanding of principles supposedly not discovered until modern times, our timeline for technological development is probably wrong. The Antikythera mechanism and computational devices. Discovered in a shipwreck off the Greek island of Antikythera, this bronze device dating to approximately 100 BC demonstrates computational sophistication that rivals modern mechanical computers. The Antikythera mechanism contains over 80 bronze gears precisely machined to track the movements of the sun, moon, and planets with extraordinary accuracy. Modern reconstruction reveals computational capabilities that weren't achieved again until the development of astronomical clocks in the 14th century. Ancient Greek civilization possessed mechanical engineering knowledge and precision manufacturing techniques that far exceeded what conventional history suggests was possible. Creating the Antikythera mechanism required precise gear-cutting techniques that demand advanced metallurgy, mathematical calculations involving complex astronomical cycles, understanding of differential gearing systems not officially invented until the 16th century, and quality control methods ensuring accuracy across dozens of precisely machined components. If ancient Greeks could create mechanical computers using bronze gear systems, other ancient civilizations could have developed equally sophisticated technologies using different materials and principles. Hieroglyphic texts describe astronomical calculations and mathematical relationships that would require computational aids to develop and verify. The precision demonstrated in pyramid construction suggests access to calculation methods more advanced than simple arithmetic. When ancient artifacts demonstrate precision manufacturing and complex calculations, they indicate technological capabilities that may have been widespread rather than exceptional. Sound technology and acoustic engineering. Recent research has revealed that ancient monuments worldwide were designed with sophisticated understanding of acoustic principles and sound technology that exceeds modern capabilities in some areas. The internal chambers of the Great Pyramid demonstrate extraordinary acoustic characteristics. The king's chamber resonates at a frequency of 110 Hz, which research shows affects human consciousness and perception. The Grand Gallery functions as a sophisticated acoustic amplifier. The entire internal structure appears designed to manipulate sound waves in specific ways. The pyramid's internal geometry creates standing wave patterns and resonance effects that would require advanced understanding of acoustic engineering principles. Similar acoustic engineering appears in ancient monuments worldwide. Newgrange in Ireland uses standing waves to amplify whispers across large chambers. Mayan pyramids create echo effects that replicate animal sounds. Hindu temples demonstrate acoustic design that enhances chanting and meditation. Greek amphitheaters achieve perfect sound distribution without modern amplification. Some researchers propose that ancient builders used sound frequency technology to reduce the effective weight of massive stones, making transportation and positioning easier. The evidence for sound levitation includes several elements. Tibetan texts describe using sound to move heavy stones. Multiple cultures preserve traditions of using acoustic methods in construction. Modern research confirms that specific frequencies can create anti-gravitational effects. The precision of ancient stone placement suggests methods that exceeded simple mechanical lifting. Ancient texts from multiple cultures describe using sound as a weapon, suggesting sophisticated understanding of acoustic technology for purposes beyond construction. When ancient monuments demonstrate acoustic engineering that exceeds modern understanding, they provide evidence of technological knowledge that has been lost rather than developed gradually. Precision machining and advanced metallurgy. Archaeological evidence reveals that ancient civilizations possessed manufacturing capabilities that rival modern precision engineering, contradicting conventional assumptions about primitive ancient technology. Discovered in Egypt's Saqqara complex, thousands of stone vases demonstrate machining precision that modern manufacturers struggle to replicate. These vases are cut from granite, basalt, and other hard stones with walls less than 2 millimeters thick. They're perfectly balanced and symmetrical to tolerances of 0.01 millimeters. They're finished with surface smoothness that requires modern polishing techniques and manufactured in quantities suggesting industrial-scale production methods. Ancient Egyptian civilization possessed tools and techniques that achieved precision matching modern industrial standards. Ancient artifacts reveal metallurgical knowledge that supposedly wasn't developed until much later. Damascus steel demonstrates carbon nanotube structures not officially discovered until the 20th century. Ancient bronze alloys show compositions that optimize strength and corrosion resistance through principles not understood until modern materials science. Iron artifacts from ancient India contain metal purities that require advanced refining techniques. Gold alloys from pre-Columbian America demonstrate sophisticated understanding of material properties. The precision evident in ancient artifacts requires cutting tools, measuring instruments, and manufacturing techniques that exceed what conventional archaeology suggests was available. The evidence suggests ancient access to diamond or harder cutting materials for precision stonework, measuring instruments accurate to fractions of millimeters, power tools capable of sustained high-speed operation, and quality control systems ensuring consistency across mass production. When ancient artifacts demonstrate tolerances and finish quality that match modern industrial standards, they indicate access to technologies more advanced than conventional history suggests. The energy systems of ancient monuments. Modern analysis of ancient monuments reveals that many were designed to generate, focus, or manipulate various forms of energy in ways that suggest sophisticated understanding of physics principles supposedly not discovered until modern times. Christopher Dunn's analysis suggests the Great Pyramid functioned as a hydrogen fuel cell using chemical reactions in the internal chambers to generate electrical power. The pyramid power system would work through a complex process. Chemical solutions flowing through the Queen's chamber would generate hydrogen gas. The hydrogen would rise through the Grand Gallery, creating pressure differentials. The King's chamber's granite would convert mechanical stress into electrical current through piezoelectric effects. The entire system would generate substantial electrical power for unknown purposes. The evidence for energy generation includes salt deposits in the Queen's chamber, consistent with chemical processing, erosion patterns suggesting liquid flow through internal passages, acoustic properties that would enhance chemical reaction efficiency, and electrical conductivity measurements showing the pyramid conducts current. Controversial research at the Bosnian Pyramid Complex has detected electromagnetic emissions, ultrasound beams, and energy fields that suggest these monuments function as technological devices rather than simple tombs. Ancient monuments worldwide show evidence of energy-related functions. Stonehenge sits on underground water flows and demonstrates electromagnetic anomalies. Mayan pyramids show evidence of electrical activity during certain astronomical alignments. Easter Island statues contain electrical conductivity, suggesting technological rather than purely artistic purposes. Scientific investigation of ancient monument energy properties consistently faces institutional resistance and funding difficulties, suggesting concerns about what such research might discover. When ancient monuments demonstrate energy-related properties and functions, they may represent technological systems whose purposes we don't yet understand, rather than purely ceremonial structures. The lost knowledge preservation systems. The evidence suggests that ancient civilizations deliberately designed their most important monuments to preserve technological knowledge through catastrophic periods, ensuring that crucial information would survive for future discovery. Rather than storing technological knowledge in fragile written records, ancient engineers encoded information in the physical structure of monuments that could survive natural disasters, wars, and civilizational collapse. Knowledge encoding worked through several methods. Mathematical constants were embedded in architectural proportions. Astronomical data was preserved in monument alignments and orientations. Engineering principles were demonstrated in construction techniques. Technological capabilities were showcased in precision manufacturing. Ancient monuments appear to contain information at multiple levels of complexity. Basic mathematical relationships accessible to any civilization with measurement capabilities, intermediate astronomical knowledge requiring significant scientific development to decode, and advanced technological principles that can only be understood by civilizations approaching the builder's capability level. The monuments seem designed to reveal their secrets progressively as human technology advances, ensuring that knowledge is rediscovered when humanity is ready to understand and apply it safely. As our technology improves, we're beginning to detect and understand technological aspects of ancient monuments that were invisible to earlier generations of researchers. When ancient monuments are designed to preserve and gradually reveal technological knowledge, they represent sophisticated long-term planning for civilizational continuity across catastrophic periods. The evidence for advanced ancient technology provides a framework for understanding how the pyramid builders achieved their impossible precision and massive scale. If they possess technologies that we've lost or never developed along our own technological path, it explains capabilities that seem impossible using primitive methods. But this raises fundamental questions about human technological development and the nature of progress itself. If advanced civilizations existed in the past and were destroyed by natural catastrophes, what does that mean for our own future? The next phase of our investigation examines how these discoveries connect to global patterns of advanced ancient construction that suggest a worldwide civilization with capabilities that exceeded those of any individual culture. Global pattern, the worldwide connection, the impossible coincidences. Across 6 continents, separated by thousands of miles, and supposedly isolated from each other by thousands of years, ancient civilizations built monuments using identical techniques that modern engineering can barely understand. These aren't similar approaches, they're exact matches in precision, method, and inexplicable capability. The megalithic precision pattern. Whether you examine the pyramids of Egypt, the stone walls of Sacsayhuaman in Peru, the temples of Baalbek in Lebanon, or the platforms of Nan Madol in Micronesia, you find the same impossible characteristics. Massive stones, fitted together with gaps of less than 1 millimeter, complex geometries that require advanced mathematical knowledge, transportation of materials across distances that challenge modern logistics, construction techniques that leave no tool marks or evidence of methods used. According to conventional archaeology, these civilizations had no contact with each other. They supposedly developed identical, impossible construction techniques independently, using different materials in different climates for different purposes. The statistical impossibility. The mathematical probability of multiple isolated civilizations independently developing identical advanced construction techniques approaches 0. When the same impossibilities appear worldwide, you're looking at connected knowledge rather than coincidental innovation. When identical advanced techniques appear simultaneously across isolated civilizations, they probably learned from common sources rather than developing identical solutions independently. The precision stone cutting worldwide. The same inexplicable precision in stone cutting and fitting appears at ancient sites across the globe, suggesting access to common technologies or knowledge systems that conventional archaeology refuses to acknowledge. Sacsayhuaman, Peru. The massive stone walls outside Cusco demonstrate the same precision fitting found in Egyptian monuments. Stones weighing over 100 tons are cut with angles and curves that fit together perfectly, creating joints so tight that a knife blade cannot be inserted between them. The stones are cut from granite and andesite, materials harder than steel, using techniques that show no tool marks or evidence of conventional cutting methods. Pumapunku, Bolivia. This site displays stone cutting precision that exceeds modern capabilities. Andesite blocks are cut with flat surfaces accurate to within 1/100th of an inch and fitted with complex interlocking joints that require 3-dimensional precision planning. The cutting technology mystery. Modern attempts to replicate the cutting precision found at these sites have failed, even using diamond-tipped tools and computer-controlled machinery. The ancient cutting achieved tolerances that our current technology struggles to match. Nan Madol, Micronesia. In the middle of the Pacific Ocean, this ancient complex demonstrates the same precision construction found on every other continent. Massive basalt logs are fitted together with perfect precision, despite being located thousands of miles from any other advanced civilization. The global precision pattern reveals The same cutting technologies and fitting techniques were being used simultaneously across the planet by civilizations that supposedly had no contact with each other. When identical manufacturing tolerances appear in ancient monuments worldwide, they indicate access to common technologies, rather than independent development of identical advanced techniques. The global transportation impossibilities. Every advanced ancient civilization faced the same impossible challenge: moving massive stones across distances that defy explanation using conventional transportation methods. The solutions they employed suggest access to technologies that we don't understand. The Egyptian granite problem. 80-ton granite blocks were supposedly moved 500 miles from Aswan to Giza. But this transportation impossibility appears worldwide, with even more challenging examples. Baalbek, Lebanon. The Temple of Jupiter contains the trilithon, 3 stone blocks weighing approximately 800 tons each. These massive stones were quarried several miles away and positioned 20 feet above ground level with precision that rivals modern construction. Moving 800-ton stones requires engineering capabilities that challenge modern heavy lifting equipment. The largest mobile cranes today can lift approximately 1,000 tons under optimal conditions, but they require extensive preparation, reinforced surfaces, and careful planning. The Ollantaytambo mystery. In Peru, massive granite blocks weighing 50 to 100 tons were transported across the Urubamba Valley and lifted to heights of several hundred feet above the valley floor. The blocks were quarried on one side of the valley and installed on the opposite side, requiring crossing a river and climbing steep terrain. Easter Island's impossible logistics. Nearly 1,000 massive stone statues were carved from volcanic rock and transported across the island to various locations. The largest statues weigh over 80 tons and were moved distances of up to 20 miles across rough terrain. The pattern of impossible transportation. In every case, ancient civilizations moved stones that pushed the limits of modern transportation technology, using methods that left no archaeological evidence of the required infrastructure. When multiple civilizations worldwide accomplished the same impossible transportation tasks using methods that left no trace, they probably employed technologies different from conventional mechanical approaches. The shared astronomical knowledge. Ancient monuments worldwide demonstrate identical sophisticated understanding of astronomical cycles, planetary movements, and cosmic phenomena that supposedly wasn't discovered until modern times. The precession knowledge pattern. Civilizations across the globe encoded knowledge of the 25,920-year precession cycle in their monuments. Egyptian pyramids align with 10,500 BC star positions. Cambodian temples at Angkor map stellar positions from the same era. Mayan calendars incorporate precession cycles with mathematical precision. European megalithic sites track precession changes across millennia. Understanding precession requires centuries of careful astronomical observation and mathematical analysis. The fact that isolated civilizations worldwide possess this knowledge suggests common sources rather than independent discovery. The eclipse prediction capabilities. Ancient monuments worldwide demonstrate ability to predict solar and lunar eclipses with accuracy that requires sophisticated mathematical models. Stonehenge functions as an eclipse prediction computer. Mayan astronomical tables predict eclipses thousands of years in advance. Chinese astronomical records show eclipse prediction accuracy, matching modern calculations. Ancient Mesopotamian texts describe eclipse cycles with mathematical precision. The planetary movement tracking. Ancient civilizations worldwide demonstrated detailed knowledge of planetary orbits and movements. Venus cycles are tracked with precision in Mayan, Egyptian, and Mesopotamian records. Mars retrograde motion is documented in multiple ancient astronomical systems. Jupiter and Saturn conjunctions are calculated and predicted across cultures. Ancient astronomical instruments demonstrate understanding of complex planetary mechanics. When identical, sophisticated astronomical understanding appears across isolated civilizations, they probably inherited this knowledge from common advanced sources rather than developing it independently. The flood geology connections. Geological evidence from ancient sites worldwide supports the flood narratives preserved in cultural traditions, suggesting that advanced civilizations were operating globally before the Younger Dryas catastrophe. The water damage evidence. Ancient monuments on every continent show geological evidence of water damage that correlates with the Younger Dryas period. Egyptian Sphinx shows water erosion from heavy rainfall. South American megalithic sites display water damage patterns. European megalithic monuments show evidence of flooding. Asian temple complexes demonstrate water erosion inconsistent with current climate. The global water damage pattern indicates the monuments showing this damage were already ancient when the Younger Dryas catastrophe occurred, suggesting construction dates much earlier than conventional archaeology allows. The rapid sea level rise evidence. At the end of the last ice age, global sea levels rose approximately 400 feet, flooding coastal areas worldwide where advanced civilizations likely operated. The submerged ruins pattern. Archaeological discoveries of sophisticated underwater structures suggest that major population centers existed in areas now covered by oceans. Yonaguni Monument off Japan shows architectural features suggesting artificial construction. Dwarka off India's coast reveals urban planning consistent with advanced civilization. Mediterranean underwater sites demonstrate sophisticated harbor engineering. Caribbean underwater structures suggest complex architectural planning. The timeline correlation. The submersion of these sites correlates with the sea level rise at the end of the Younger Dryas, supporting the timeline described in ancient flood narratives. When geological evidence of water damage and submersion appears globally at ancient sites, it supports historical accounts of worldwide catastrophes that destroyed earlier advanced civilizations. The technology diffusion problem. The speed and consistency with which advanced construction techniques appeared worldwide suggests technology transfer mechanisms that conventional archaeology cannot explain using gradual cultural diffusion models. The simultaneous appearance pattern. Advanced megalithic construction techniques appear almost simultaneously across continents that supposedly had no contact. Precision stone cutting emerges in Egypt, Peru, and Asia within similar timeframes. Astronomical knowledge appears in multiple civilizations without gradual development evidence. Advanced mathematics shows up worldwide without evidence of step-by-step discovery processes. If these techniques developed independently, each civilization should show evidence of gradual experimentation, failed attempts, and incremental improvement over centuries or millennia. The missing development evidence. Archaeological investigation consistently fails to find evidence of the gradual development process that independent invention would require. No experimental stone-cutting sites showing learning curves. No failed astronomical monuments demonstrating trial-and-error development. No intermediate mathematical systems showing gradual advancement towards sophistication. The inherited knowledge model. The evidence better fits a model where multiple civilizations inherited advanced knowledge from common sources, then applied that knowledge using locally available materials and adapted to local conditions. The knowledge degradation pattern. Rather than showing improvement over time, many ancient achievements demonstrate capabilities that later civilizations couldn't replicate, suggesting knowledge loss rather than gradual development. When advanced techniques appear simultaneously worldwide without development evidence, they probably represent inherited knowledge rather than independent innovation. The suppression of global evidence. The systematic suppression of evidence for worldwide advanced ancient civilizations reveals institutional resistance to conclusions that would require fundamental revision of accepted historical narratives. The compartmentalization strategy. Rather than examining global patterns comprehensively, academic institutions compartmentalize research by region, time period, and specialization, preventing recognition of worldwide connections. The dating resistance. When sites worldwide produce evidence of greater age than conventional chronology allows, dating results are often disputed, suppressed, or ignored rather than integrated into broader historical understanding. The technology denial. Evidence of advanced ancient technologies is consistently downplayed or explained away rather than seriously investigated, preventing recognition of capabilities that would challenge conventional development timelines. The career consequences. Researchers who attempt to study global patterns of advanced ancient civilization face professional consequences that discourage comprehensive investigation of worldwide connections. When institutional resistance prevents comprehensive study of global patterns in ancient evidence, Consider whether protecting established narratives has become more important than pursuing historical truth. The global pattern of advanced ancient construction reveals a worldwide civilization with capabilities that exceeded those of any individual culture described in conventional history. This evidence suggests that human technological development followed a different path than we've been taught, one that included advanced capabilities that were lost during catastrophic periods and only partially recovered by later civilizations. But understanding the full implications of this evidence requires examining how professional engineers and construction experts evaluate these ancient achievements when they apply their real-world experience to analyzing what was supposedly accomplished using primitive methods. Engineering perspective: what professionals say when experience challenges theory. There's a remarkable disconnect between what academic archaeologists claim about pyramid construction and what professional engineers conclude when they examine the same evidence. While archaeologists defend theories developed in libraries and lecture halls, engineers base their conclusions on decades of hands-on experience, moving heavy materials, and achieving precision construction in the real world. Engineers who specialize in heavy construction, precision manufacturing, and large-scale project management consistently reach different conclusions about pyramid construction than academic archaeologists who have never built anything comparable. Engineers understand the practical limitations of materials, the physics of moving massive loads, and the precision requirements for maintaining tight tolerances across large structures. Their skepticism about conventional pyramid theories comes from understanding what's actually possible using proposed methods. When engineers examine the Great Pyramid using their professional expertise, they reach remarkably consistent conclusions, regardless of their individual backgrounds, companies, or countries. This convergence of expert opinion carries more weight than theoretical speculation by people who lack construction experience. When people who actually do this kind of work for a living tell you something is impossible, that expertise is worth more than academic theories developed by people who have never moved a heavy stone or achieved precision construction. The heavy lifting reality check. Modern heavy construction professionals understand the engineering requirements for moving and positioning massive stones better than anyone else on Earth. Their analysis of pyramid construction reveals impossibilities that academic theories simply ignore. Mike Henderson, senior crane operator with 35 years experience, states, "I've been lifting heavy loads my entire career, and I can tell you that moving 80-ton stones with the precision they achieved at Giza would challenge our best modern equipment. The idea that ancient workers did this with ropes and wooden rollers is ridiculous. Moving 80-ton loads safely requires reinforced steel frames capable of distributing massive weights, hydraulic systems generating thousands of pounds of lifting force, precision control systems allowing millimeter-accurate positioning, multiple backup safety systems, preventing catastrophic failure, and specialized transport vehicles with computer-controlled stability systems." Sarah Chen, structural engineer, explains, "The tolerances we see in pyramid construction exceed what I can achieve with laser-guided equipment and computer-controlled systems. Either these ancient builders had technology we don't understand, or our dating of these structures is completely wrong." Professional engineers understand that supporting massive stone blocks requires sophisticated knowledge of load distribution, stress analysis, and structural engineering that supposedly didn't exist in ancient times. Installing 80-ton stones with gaps of less than 1 millimeter requires precision control that challenges modern computer-guided systems. Achieving this precision with primitive methods is physically impossible. When professionals who specialize in moving massive loads say ancient methods couldn't accomplish observed results, their experience-based conclusions carry more authority than theoretical speculation. The materials science perspective. Engineers who work with granite, limestone, and other hard materials bring essential knowledge about what's actually possible when cutting and shaping stone using different tools and techniques. Dr. James Morrison, materials engineer, states, "I've spent 25 years working with granite in manufacturing applications. The precision cuts and drill holes we see in pyramid construction require diamond-tipped tools operating at high speeds with excellent vibration control. Copper chisels couldn't scratch the surface of granite, literally. Materials science reveals that granite rates 6 to 7 on the Mohs hardness scale, while copper rates only 3. This means granite is literally twice as hard as copper. Trying to cut granite with copper tools is like trying to cut steel with aluminum foil. Professional stoneworkers understand that even modern carbide and diamond tools wear out quickly when cutting granite. Ancient copper tools would become unusable within minutes of contact with hard stone. Mark Stevens, master stonemason with 40 years experience, explains, "I've cut thousands of stone blocks in my career, and I know what different tools can accomplish." The precision and smoothness we see in ancient Egyptian stonework requires power tools, diamond cutting wheels, and polishing equipment that didn't exist thousands of years ago. Professional stoneworkers recognize that achieving the mirror-like finishes found on ancient artifacts requires progressive grit polishing using increasingly fine abrasives, consistent pressure application across complex surfaces, vibration-free tool operation, maintaining steady contact, and multiple finishing stages using different techniques and materials. Calculating the time required to shape pyramid stones using primitive methods reveals production rates that make the conventional timeline impossible. When professionals who work with stone daily say ancient cutting methods couldn't achieve observed results, their hands-on knowledge carries more weight than theoretical calculations by people who have never cut stone professionally. The project management impossibility. Engineers who specialize in managing large construction projects understand the organizational and logistical requirements that make conventional pyramid construction theories practically impossible. Robert Chen, construction project manager, states, "I've managed multi-billion-dollar construction projects with thousands of workers and unlimited budgets. The organizational requirements for building the Great Pyramid using primitive methods would exceed anything we accomplish today with modern communication, transportation, and management systems." Successfully managing thousands of workers requires detailed planning and scheduling systems, coordinating multiple work crews, supply chain management ensuring materials arrive when needed, quality control systems, maintaining precision across all work, communication networks, enabling coordination between work groups, and safety systems protecting workers from industrial hazards. Conventional theories suggest that 20,000 workers built the Great Pyramid over 20 years. Managing this workforce using ancient communication methods would require organizational capabilities that exceed those of most modern corporations. Feeding, housing, and equipping 20,000 workers for 20 years while maintaining productivity would require supply chain management that challenges modern logistics companies with computer systems and global transportation networks. Lisa Rodriguez, industrial engineer, explains, "The precision and consistency we see in pyramid construction indicates quality control systems that rival modern manufacturing. Achieving this with primitive tools and ancient management methods is impossible. Installing 2.3 million stone blocks with perfect fit and alignment requires coordination between quarrying, transportation, cutting, and installation teams that would challenge modern project management with radio communication and computer scheduling." When professionals who manage large construction projects say ancient organizational methods couldn't accomplish pyramid construction, their experience managing real projects carries more authority than theoretical speculation. The precision manufacturing assessment. Engineers who specialize in precision manufacturing recognize that achieving the tolerances found in pyramid construction requires capabilities that exceed what primitive tools could accomplish. David Park, precision machinist, states, "I've worked in aerospace manufacturing where tolerances of 0.001 inches are standard. The precision I see in pyramid construction requires measurement systems, cutting tools, and quality control methods that are more advanced than what ancient Egyptians supposedly possessed. Achieving tolerances of less than 1 millimeter across massive structures requires measurement systems accurate to fractions of the final tolerance, cutting tools capable of maintaining precision over extended periods, environmental controls preventing thermal expansion and contraction, and quality verification systems, ensuring accuracy throughout production. Creating the precision evident in pyramid construction requires measurement tools accurate to within 0.1 millimeters. Ancient Egyptians supposedly used rope and wooden measuring rods, tools incapable of the required precision." Jennifer Walsh, quality control engineer, explains, "The consistency we see across pyramid construction indicates statistical process control that rivals modern manufacturing. This level of quality assurance requires measurement tools and analytical methods that didn't exist in ancient times." Professional engineers understand that stone expands and contracts with temperature changes. Achieving tight fits between massive stone blocks requires compensation for thermal expansion that demonstrates advanced understanding of materials science. The consistency of precision across millions of stone blocks indicates quality control systems that monitor and maintain standards throughout production, capabilities that require systematic measurement and analysis methods. When professionals who achieve tight tolerances daily say ancient precision exceeds what primitive methods could accomplish, their manufacturing experience provides more reliable assessment than theoretical speculation. The transportation engineering analysis. Engineers who specialize in heavy transportation and logistics bring essential knowledge about what's required to move massive loads across long distances using different methods and technologies. Carlos Martinez, heavy haul transportation specialist, states, "I've moved 200-ton loads across hundreds of miles using the best equipment available. The idea that ancient workers moved 80-ton granite blocks 500 miles using wooden rollers and human power violates basic physics and engineering principles. Moving 80-ton loads requires load distribution systems, preventing crushing of support surfaces, friction reduction methods, minimizing resistance during movement, directional control systems, maintaining accurate routing, power sources generating sufficient force to overcome inertia and friction, and safety systems preventing catastrophic load shifts. Physics calculations show that moving 80-ton loads on wooden rollers would require forces that thousands of workers couldn't generate, even under optimal conditions." Maria Gonzalez, logistics engineer, explains, "The coordination required to move pyramid stones from quarries to construction sites would challenge modern transportation companies with GPS tracking, radio communication, and computer scheduling systems. Transporting massive loads requires engineered routes with reinforced surfaces capable of supporting concentrated weights, gradient controls preventing runaway loads on slopes, bridge and ferry systems for crossing water obstacles, and maintenance systems keeping routes operational throughout transport campaigns. Moving thousands of massive stones would require transportation infrastructure that would leave extensive archaeological evidence that has never been found." When professionals who move massive loads say ancient transportation methods couldn't accomplish observed results, their logistics expertise provides more reliable assessment than theoretical speculation about primitive methods. The surveying and alignment expertise. Professional surveyors and alignment specialists understand the technical requirements for achieving the precision alignments found in pyramid construction. Thomas Kim, professional land surveyor, states, "The accuracy of pyramid alignment with true north requires surveying techniques and instruments that exceed what ancient Egyptians supposedly possessed. Achieving this precision without modern instruments would require methods we don't understand. Accurate alignment over large distances requires reference systems establishing true north with astronomical precision, measurement instruments maintaining accuracy across changing environmental conditions, error correction methods, compensating for Earth curvature and atmospheric effects, and verification systems ensuring accuracy throughout extended construction periods. Establishing true north to within 3 arc minutes requires astronomical observation techniques and mathematical calculations that supposedly weren't developed until much later in history." Patricia Wilson, geodetic surveyor, explains, "The geometric relationships embedded in pyramid construction demonstrate understanding of Earth measurement and spherical geometry that rivals modern geodetic science. Maintaining accuracy across structures hundreds of feet in dimension requires surveying capabilities that challenge modern equipment using satellite guidance and laser measurement systems. Achieving consistent precision requires compensation for atmospheric distortion, affecting sight lines, thermal expansion, changing measurement dimensions, ground settlement altering reference points, and magnetic variation affecting compass readings. When professionals who achieve precision alignment daily say ancient surveying methods couldn't accomplish pyramid accuracy, their measurement experience provides more reliable assessment than theoretical speculation." The unanimous professional conclusion. When engineers from multiple specialties examine pyramid construction using their professional expertise, they reach remarkably consistent conclusions that challenge conventional archaeological theories. Regardless of their specific field, whether heavy construction, precision manufacturing, materials science, or project management, Professional engineers consistently conclude that pyramid construction required capabilities beyond what conventional archaeology suggests was available. This professional consensus comes from engineers who actually accomplish similar tasks using modern technology. Their skepticism about ancient methods comes from understanding the real-world requirements for precision construction and heavy materials handling. Professional engineers recognize that achieving pyramid construction standards requires technologies and methods more advanced than what conventional history suggests ancient Egyptians possessed. When people who actually build things for a living unanimously agree that conventional theories don't work, their collective expertise carries more weight than academic speculation by people who lack hands-on construction experience. The engineering assessment suggests that pyramid builders either possess technologies we don't understand or that the structures are much more recent than conventional dating suggests. When professionals across multiple engineering disciplines reach the same conclusions about ancient construction impossibilities, their experience-based assessment provides the most reliable evaluation of what these achievements actually required. The unanimous conclusion of professional engineers that pyramid construction required capabilities beyond primitive methods provides the most credible assessment of what these monuments actually represent. But understanding why this professional expertise is ignored requires examining how alternative explanations are systematically dismissed and suppressed. The next phase of our investigation explores how institutional resistance to challenging evidence shapes public understanding and prevents recognition of alternative theories that might better explain the engineering impossibilities. We've discovered the counter-arguments refuting the official story, dismantling the ramp theory. The most commonly cited explanation for pyramid construction is that ancient Egyptians used ramps to transport massive stones to great heights. This theory has dominated textbooks for decades, but detailed engineering analysis reveals that it's physically impossible using the materials and methods supposedly available. The straight ramp impossibility. A straight ramp to reach the pyramid's 481-foot height with a manageable 10-degree slope would need to be nearly 3,000 feet long. This would require more material than the pyramid itself and would interfere with construction of the pyramid's base. To support 80-ton loads, the ramp would need to be at least 30 feet wide to provide stability for massive stone transport, reinforced with stone foundations to prevent collapse under load, maintained throughout the 20-year construction period, and built with more precision than many modern highways. The spiral ramp problems. Some archaeologists propose spiral ramps winding around the pyramid sides, but this creates even worse engineering challenges. The ramp would need to be continuously rebuilt as the pyramid grew higher. Corner turns would be impossible for 80-ton loads without modern steering systems. The ramp structure would interfere with the precision fitting of pyramid stones. No archaeological evidence of such massive ramp systems has ever been found. Mark Lehner's ramp experiments. Even archaeologist Mark Lehner, who supports conventional theories, admitted that experimental attempts to move large stones using proposed ramp methods have failed consistently. When the most commonly cited explanation for pyramid construction fails basic engineering analysis, it indicates that conventional theories are based on wishful thinking rather than practical understanding of construction requirements. The workforce organization myth. Conventional archaeology claims that 20,000 workers built the Great Pyramid over 20 years using primitive tools and simple organization. This theory collapses under analysis of what such a workforce would actually require in terms of logistics, organization, and productivity. The food and water requirements. Supporting 20,000 workers in the desert for 20 years would require daily delivery of approximately 60,000 pounds of food, fresh water transport for drinking, cooking, and hygiene needs, storage facilities protecting supplies from heat and spoilage, and waste management systems handling human and food waste. Ancient Egypt didn't have the transportation infrastructure, preservation technology, or organizational systems to support such massive workforce requirements using available technology. The productivity problem. Calculations show that achieving the required construction rate would need each worker to quarry, transport, and install 1.1 stone blocks per day, impossible using primitive tools, even if workers did nothing else. The skills mix reality. Pyramid construction would require master stonemasons for precision cutting and fitting, experienced heavy equipment operators for moving massive loads, skilled surveyors for maintaining accuracy and alignment, and specialized craftsmen for internal chamber construction. The archaeological evidence gap. Despite claims of 20,000 workers over 20 years, archaeologists have found no worker housing capable of supporting such numbers, no food storage facilities adequate for massive workforce needs, no tool manufacturing sites producing equipment for thousands of workers, and no waste disposal sites handling 20 years of human occupation. When claimed workforce requirements exceed what archaeological evidence supports and what logistics could accomplish, the workforce estimates are probably wrong rather than the physical evidence. The tool technology deception. Archaeological museums worldwide display collections of primitive copper tools supposedly used to build the pyramids, but engineering analysis reveals that these tools couldn't accomplish the precision work evident in pyramid construction. The copper tool experiments. Multiple research teams have attempted to replicate pyramid stonework using ancient tool collections. University of Cambridge experiments in 2008 showed copper chisels destroyed within 30 minutes of granite contact. Nova documentary tests in 2013 showed teams of skilled craftsmen failed to cut single granite blocks using copper tools. A Japanese research team in 2017 used computer analysis to prove copper tools insufficient for required cutting rates. These experiments consistently show that copper tools become unusable quickly when applied to hard stone, produce rough surfaces rather than precision cuts, and achieve cutting rates too slow for pyramid construction timelines. The toolware mathematics. Calculations based on experimental results show that shaping pyramid granite blocks using copper tools would require thousands of tool replacements per stone block, copper consumption exceeding Egypt's total ancient production, and work rates so slow that construction would take centuries rather than decades. The missing tool evidence. If copper tools were actually used for pyramid construction, archaeologists should find massive quantities of worn and discarded copper implements, tool manufacturing sites producing equipment for pyramid construction, copper mine expansion evidence supporting increased tool production, and recycling facilities processing massive quantities of worn copper tools. None of this supporting evidence has been found. The alternative tool theory. The precision evident in pyramid construction suggests access to cutting tools made from harder materials, possibly diamond, corundum, or unknown technologies that left no archaeological trace. When experiments consistently show that proposed ancient tools couldn't accomplish observed results, the tools used were probably different from what conventional archaeology suggests. The timeline impossibility. Conventional archaeology claims the Great Pyramid was built in 20 years, but detailed analysis of construction requirements reveals that this timeline is physically impossible using proposed ancient methods. The block installation rate. The pyramid contains approximately 2.3 million stone blocks. Completing construction in 20 years requires installing 315 blocks per day, one block every 2.5 minutes during 12-hour workdays, with continuous installation without breaks for weather, accidents, or maintenance. Each block installation requires quarrying stone from distant locations, transportation across hundreds of miles, precision cutting and fitting at the construction site, and careful positioning using primitive lifting methods. The quality control problem. Achieving the precision evident in pyramid construction requires detailed measurement and inspection of each block, corrections and adjustments for proper fitting, verification of alignment and levelness throughout construction, and coordination between multiple work crews handling different aspects. The seasonal work limitations. Construction in ancient Egypt would be limited by Nile flood seasons, preventing quarry access and material transport, extreme summer heat making heavy labor dangerous, sandstorms and weather delays interrupting precision work, and religious festivals and agricultural cycles reducing available workforce. The realistic timeline analysis. Engineering consultants who analyze pyramid construction using practical construction rates conclude that building the Great Pyramid using proposed ancient methods would require 200 to 500 years, not 20 years. When required construction rates exceed what practical analysis suggests is possible, either the timeline is wrong or the construction methods were more advanced than conventional theories suggest. The quarrying and transportation fraud. Conventional explanations for how ancient Egyptians quarried and transported massive pyramid stones fail detailed engineering analysis and ignore the absence of supporting archaeological evidence. The quarrying tool problem. Cutting massive blocks from limestone and granite quarries requires tools harder than the stone being cut, power sources for sustained cutting operations, precision measurement for achieving required block dimensions, and quality control ensuring structural integrity of cut blocks. Conventional quarrying theories ignore that copper and bronze tools couldn't cut granite effectively, wooden wedges couldn't split massive blocks cleanly, and fire-setting techniques couldn't achieve the precision evident in pyramid blocks. The transportation infrastructure gap. Moving millions of stone blocks would require reinforced roads capable of supporting massive loads, bridge systems crossing water obstacles, loading and unloading facilities at quarries and construction sites, and maintenance systems keeping transportation routes operational. The archaeological evidence absence. Despite claims of massive quarrying and transportation operations, archaeologists have found no road systems engineered for heavy stone transport, no bridge foundations designed for massive load crossing, no loading ramps or facilities at supposed quarry sites, and no intermediate storage areas for blocks awaiting transport. The modern quarrying comparison. Current granite quarrying operations require diamond wire saws for precision cutting, hydraulic splitters for block separation, heavy machinery for loading and transportation, and quality control systems, ensuring block specifications. When proposed ancient quarrying methods lack the tools, infrastructure, and evidence that such operations would require, the actual methods were probably different from conventional explanations. The astronomical alignment dismissal. Mainstream archaeology consistently dismisses or minimizes the sophisticated astronomical alignments in pyramid construction, despite mounting evidence that these alignments demonstrate advanced knowledge that conventional chronology can't explain. The precision minimization strategy. When confronted with pyramid astronomical alignments, conventional archaeologists typically claim the alignments are approximate rather than precise, suggest the astronomical knowledge was primitive, despite mathematical sophistication, argue that astronomical alignments are coincidental rather than intentional, and dismiss the significance of alignments that don't match conventional construction dates. This dismissal ignores that the astronomical alignments in pyramid construction demonstrate mathematical precision that exceeds many modern astronomical calculations, understanding of precession cycles that wasn't officially discovered until much later, coordination of multiple monuments to create star maps of specific time periods, and integration of astronomical knowledge with precision engineering capabilities. The Robert Bauval suppression. Despite computer verification of the Orion correlation theory, mainstream archaeology continues to reject evidence that pyramid alignments point to 10,500 BC rather than 2,500 BC. The alternative dating resistance. Rather than seriously investigating what astronomical evidence suggests about pyramid age, conventional archaeology dismisses all alternative dating proposals without detailed refutation. The cultural bias problem. The dismissal of astronomical evidence often reflects cultural assumptions that ancient civilizations couldn't possess sophisticated knowledge rather than objective evaluation of mathematical evidence. When institutions consistently minimize or dismiss evidence that challenges their preferred theories, they're often protecting established narratives rather than following evidence to logical conclusions. The burden of proof reversal. Perhaps most revealing is how mainstream archaeology handles the burden of proof when defending conventional pyramid theories. Rather than proving their explanations work, they demand that alternative theories prove themselves while ignoring the failure of conventional explanations. The impossible standard. Conventional archaeology demands that alternative theories provide complete explanations for every aspect of pyramid construction, archaeological evidence for every proposed ancient technology, perfect solutions to problems that conventional theories can't address, and acceptance from institutions that have invested careers in conventional explanations. This standard ignores that conventional pyramid theories fail their own burden of proof. Ramp theories lack archaeological evidence and engineering feasibility. Tool theories fail experimental verification and material science analysis. Timeline theories ignore practical construction rates and logistical requirements. Workforce theories lack supporting evidence and organizational plausibility. The double standard problem. Alternative theories are required to meet evidentiary standards that conventional theories don't meet themselves, creating impossible barriers to paradigm change. The evidence quality comparison. When evaluated objectively, alternative theories often provide better explanations for observed evidence than conventional theories that have institutional support. When institutions protect failed theories by demanding impossible standards from alternatives while ignoring the failures of preferred explanations, they're defending paradigms rather than pursuing truth. The systematic failure of conventional explanations for pyramid construction reveals that mainstream archaeology has built an entire theoretical framework on assumptions that can't withstand detailed engineering analysis. But understanding why these failed theories persist requires examining the broader cultural and institutional forces that resist challenging evidence. The next phase of our investigation explores how the evidence we've examined impacts our understanding of human civilization and what it means for our future development. Cultural impact. What this means for society. The foundation of modern identity. The conventional story of pyramid construction isn't just about ancient engineering, it's a cornerstone of how modern civilization understands itself. We've been taught that human progress follows a steady upward trajectory from primitive beginnings to our current technological sophistication. The pyramids represent a carefully managed piece of this narrative. Impressive ancient achievement that nonetheless confirms our superiority over past civilizations. This narrative matters so deeply because our entire educational system, cultural identity, and sense of progress depends on maintaining specific beliefs about how human civilization developed. We teach children that we're the most advanced humans who ever lived, that technology always improves over time, and that ancient peoples were primitive compared to us. The psychological investment. Acknowledging that ancient civilizations might have possessed capabilities we lack would require fundamental revision of how we understand human achievement and progress. This threatens not just academic theories, but personal and cultural identity built on assumptions about modern superiority. The educational infrastructure. Schools, museums, documentaries, and textbooks worldwide have invested billions of dollars in educational materials based on conventional historical narratives. Acknowledging fundamental errors would require massive revision of educational content and institutional credibility. The lesson about cultural resistance. When evidence challenges foundational beliefs about human progress and modern superiority, expect resistance that goes far beyond scientific disagreement into questions of cultural identity and institutional investment. National pride and tourism economics. For Egypt, the conventional pyramid narrative serves crucial economic and political purposes that create powerful incentives to resist alternative explanations, regardless of what evidence might suggest. The tourism revenue factor. Egypt's archaeological sites generate hundreds of millions of dollars annually in tourism revenue. The pyramid narrative of ancient Egyptian achievement attracts millions of visitors who want to experience the legacy of a great civilization. Alternative theories threaten this because if the pyramids were built by an earlier, unknown civilization, or if they're much older than currently believed, it would diminish Egypt's role as inheritor of this achievement and potentially reduce tourist interest in Egyptian cultural heritage. The national identity problem. Modern Egyptian identity is closely tied to being descendants of the civilization that built the pyramids. Acknowledging that the builders might have been different people from a different time period would require revision of national historical narrative and cultural pride. The international heritage politics. Egypt's status in international heritage organizations, archaeological partnerships, and cultural exchange programs depends partly on its role as guardian of one of humanity's greatest ancient achievements. The economic stakeholder resistance. Tour operators, hotels, museums, and thousands of businesses built around pyramid tourism have financial interests in maintaining narratives that attract international visitors and support the current heritage interpretation industry. The lesson from economic incentives. When substantial financial and political interests depend on maintaining specific historical narratives, expect institutional resistance to evidence that might disrupt profitable cultural and tourism industries. The religious and philosophical implications. Perhaps most significantly, the evidence for advanced ancient civilizations challenges religious and philosophical frameworks that shape how billions of people understand human history and purpose. The biblical timeline challenge. Many religious traditions maintain chronological frameworks that place human civilization within specific time periods. Evidence for advanced civilizations existing much earlier than these frameworks creates theological problems that extend far beyond archaeology. This creates religious resistance, because if human civilization is much older and more advanced than religious texts suggest, it raises questions about the accuracy and authority of religious historical accounts that form the foundation of faith for billions of people. The progressive narrative disruption. Western philosophy has developed elaborate theories about human progress, enlightenment, and technological development that assume steady advancement from primitive origins. Evidence of cyclical civilization with periods of advanced achievement followed by collapse challenges these fundamental philosophical assumptions. The scientific materialism problem. Modern scientific establishment has invested heavily in materialist explanations for human development that exclude possibilities of advanced ancient technologies or knowledge systems. Acknowledging such possibilities would require revision of fundamental assumptions about how technological progress occurs. The educational philosophy impact. Teaching that ancient civilizations might have possessed capabilities we lack would fundamentally change how we educate children about human potential, progress, and the relationship between past and present achievement. The lesson from philosophical resistance. When evidence challenges fundamental religious and philosophical frameworks about human history and progress, expect resistance that transcends scientific disagreement and enters the realm of worldview protection. The technology and innovation paradigm. Our entire approach to technological development is based on assumptions about linear progress and the superiority of modern methods. Evidence for advanced ancient technologies challenges these assumptions in ways that could revolutionize how we approach innovation and problem solving. The linear progress assumption. Modern innovation assumes that technology always improves over time and that current methods represent the best approaches developed so far. Evidence of ancient technologies that exceed modern capabilities suggests that progress isn't always linear and that we might have lost valuable knowledge. This means for modern innovation that if ancient civilizations developed technologies using different principles than our current approach, studying their methods might reveal new possibilities for solving modern engineering challenges. The materials science implications. Evidence for ancient precision manufacturing and advanced metallurgy suggests that past civilizations might have developed materials and techniques that could enhance modern manufacturing capabilities. The energy technology possibilities. If ancient monuments functioned as energy generation or manipulation systems, understanding their principles could lead to breakthrough technologies for sustainable energy production. The alternative development paths. Rather than assuming our current technological path is optimal, evidence for advanced ancient technologies suggests that other development paths might lead to capabilities we haven't achieved. The lesson from innovation implications. When evidence suggests that ancient civilizations achieved capabilities through methods we don't understand, it opens possibilities for technological advancement that could benefit modern society if we're willing to learn from the past. The educational system transformation. Acknowledging the evidence we've examined would require fundamental changes in how we educate people about history, human capabilities, and the nature of progress itself. The curriculum revolution. Teaching accurate history would require revision of textbooks across multiple subjects and grade levels, retraining of teachers who learned conventional narratives during their education, development of new educational materials that present evidence objectively, and integration of engineering and scientific analysis into historical education. Educational transformation would mean that students would learn to evaluate historical claims using engineering analysis, scientific evidence, and critical thinking, rather than accepting authoritative narratives without question. The critical thinking enhancement. Education that acknowledges ancient achievements honestly would teach students how to evaluate claims against physical evidence, the importance of practical expertise in assessing historical theories, the role of institutional bias in shaping accepted narratives, and the value of interdisciplinary analysis combining multiple fields of knowledge. The human potential implications. Rather than teaching that we represent the pinnacle of human achievement, education could explore the full range of human capabilities demonstrated throughout history and encourage students to consider what we might accomplish. The problem-solving approach. Education that acknowledges ancient advanced technologies could inspire innovative approaches to modern challenges by encouraging students to consider alternative methods and principles. The lesson from educational transformation. When education becomes more honest about evidence and less protective of established narratives, it produces students better equipped to think critically and solve complex problems. The scientific method renaissance. Perhaps most importantly, honest examination of pyramid evidence could restore scientific integrity by prioritizing evidence evaluation over paradigm protection and institutional authority. The evidence-first approach. Rather than defending established theories regardless of evidence, scientific investigation could return to following evidence wherever it leads, even when it challenges established beliefs. Scientific renaissance would mean that research would be guided by curiosity about truth rather than protection of institutional investment in particular theories or funding sources. The interdisciplinary integration. Honest investigation of ancient achievements requires combining expertise from multiple fields: engineering, geology, astronomy, physics, and archaeology, rather than defending disciplinary boundaries that prevent comprehensive analysis. The institutional reform possibilities. Acknowledging systematic suppression of evidence could lead to reforms that prevent institutional bias from distorting scientific research and ensure that challenging discoveries receive proper investigation. The public education impact. When scientific institutions demonstrate commitment to evidence over authority, public trust in science increases and people become more willing to support research that might lead to uncomfortable conclusions. The innovation acceleration. Scientific research guided by evidence rather than paradigm protection could lead to breakthrough discoveries by exploring possibilities that institutional bias currently excludes. The lesson from scientific renewal. When institutions prioritize truth over convenience, scientific progress accelerates and public confidence in research increases, creating positive feedback that benefits society broadly. The cultural implications of honest pyramid research extend far beyond archaeology into questions of education, innovation, and human potential. But understanding these implications fully requires examining what current evidence suggests about humanity's true timeline and capabilities. The next phase of our investigation constructs a new timeline for human civilization based on the evidence we've examined, revealing a more complex and remarkable story of human achievement than conventional narratives suggest. The real timeline, reconstructing human history. Before the catastrophe, the Golden Age 25,000 to 12,800 years ago. Based on the evidence we've examined, human civilization appears to have reached remarkable heights long before conventional archaeology suggests advanced societies existed. This period, remembered in myths as the Golden Age or the time of the gods, represents humanity's first technological peak, the advanced antediluvian civilization. During this period, evidence suggests global communication and transportation networks connecting continents, advanced understanding of astronomy, mathematics, and engineering, precision manufacturing capabilities, matching or exceeding modern standards, energy technologies that we don't fully understand today, and sophisticated knowledge preservation systems designed to survive catastrophes. The archaeological evidence reveals that sites like Göbekli Tepe, Gunung Padang, and other megalithic complexes demonstrate construction capabilities during this period that exceed what conventional chronology allows. These weren't isolated achievements. They represent a global civilization with shared knowledge and technologies. The astronomical knowledge peak. The precise astronomical alignments in monuments worldwide suggest that this civilization possessed complete understanding of precession cycles and their significance. Accurate measurement of Earth's dimensions in celestial mechanics, mathematical systems incorporating advanced geometric and numerical relationships, and observatory networks tracking celestial events across multiple continents. The technology integration. Rather than developing along the same path as modern civilization, this antediluvian society appears to have mastered sound and frequency technologies for construction and other purposes, electromagnetic energy systems using natural Earth properties, material science producing alloys and composites with superior properties, and precision manufacturing using methods we haven't identified. The global coordination. Evidence suggests this civilization operated on a planetary scale with shared standards for measurement, mathematics, and construction. Coordinated monument building, encoding identical astronomical information, knowledge preservation systems, ensuring important information survived regional disasters, and communication methods, enabling coordination across vast distances. The lesson from the Golden Age is that human technological capability peaked much earlier than conventional history suggests, following development paths different from our current approach, but achieving results that we struggle to replicate today. The Younger Dryas Catastrophe. The Great Destruction 12,800 to 11,600 years ago. Around 12,800 years ago, the advanced antediluvian civilization was destroyed by cosmic impacts that triggered global climate disruption, massive flooding, and the collapse of technological society worldwide. The cosmic impact evidence. Geological evidence confirms that multiple comet fragments struck Earth during this period, causing massive firestorms across North America and Europe. Sudden climate cooling lasting over 1,000 years, extinction of most large mammals in North America, disruption of ocean currents and weather patterns globally, and catastrophic flooding as ice sheets melted and reformed. This catastrophe accomplished the following. Within a few decades, the global infrastructure of advanced civilization was destroyed, populations were decimated, and technological knowledge was largely lost. The survival and preservation efforts. Evidence suggests that some members of the advanced civilization anticipated the catastrophe and took measures to preserve crucial knowledge through construction of monuments designed to survive global disasters, encoding of important information in permanent stone structures, establishment of knowledge repositories in geographically protected locations, and training of survivor populations in essential technologies and knowledge. The knowledge fragmentation. As the global civilization collapsed, different survivor groups preserved different aspects of the original knowledge base. Astronomical and mathematical knowledge was preserved in some locations. Engineering and construction techniques were maintained in others. Technological capabilities were reduced to simpler versions adapted to available materials, and religious and cultural systems maintained oral transmission of historical memories. The geographic refugia. Some areas provided better protection during the catastrophic period, including high-altitude locations protected from flooding, geographically isolated regions with stable food sources, areas with natural resources supporting technological reconstruction, and locations with favorable climate conditions during the cooling period. The lesson from the catastrophe is that advanced civilizations are vulnerable to cosmic events that can destroy global infrastructure and force humanity to rebuild from surviving fragments of knowledge. The recovery period. Rebuilding civilization, 11,600 to 7,000 years ago. Following the Younger Dryas catastrophe, survivor populations gradually rebuilt civilization using preserved knowledge combined with adaptations to changed environmental conditions. The knowledge reconstruction process. Different survivor groups worked to restore technological capabilities by combining preserved advanced knowledge with practical adaptations, developing new techniques using available materials and resources, establishing educational systems to transmit complex information, and creating institutional structures to maintain knowledge across generations. The archaeological record shows that during this period, rather than gradual development from primitive origins, we see sophisticated capabilities appearing suddenly in multiple locations as survivor populations applied preserved knowledge. The regional specialization pattern. Different areas developed expertise in different aspects of the original civilization. Egypt focused on precision construction, astronomical knowledge, and mathematical systems. Mesopotamia specialized in urban planning, agriculture, and written language systems. The Indus Valley concentrated on water management, standardization, and quality control systems. Peru developed megalithic construction, transportation, and material science. China emphasized organizational systems, technological innovation, and manufacturing. The monument construction projects. During this period, survivor civilizations built monuments that served multiple purposes: including demonstrating preserved technological capabilities, encoding astronomical and mathematical knowledge for future generations, establishing cultural identity, connecting to the lost civilization, and creating landmarks that could survive future catastrophes. The gradual knowledge loss. Despite preservation efforts, advanced knowledge continued to erode. Complex technologies required resources and infrastructure that no longer existed. Specialized knowledge was lost when expert practitioners died. Environmental changes made some techniques no longer applicable, and political disruptions interrupted knowledge transmission systems. The lesson from the recovery period is that civilizational rebuilding is possible using preserved knowledge, but maintaining advanced capabilities requires infrastructure and resources that may not be immediately available after catastrophic events. The Classical Period. Inheritance management. 7,000 to 2,000 years ago. By 7,000 years ago, the recovery civilizations had stabilized into the societies we recognize as classical antiquity: Egypt, Mesopotamia, Greece, Rome, and others. These civilizations were managing and applying inherited knowledge rather than developing it originally. The Egyptian inheritance. Ancient Egyptian civilization represents the most successful preservation of antediluvian knowledge through maintaining precision construction techniques for building pyramids and temples, preserving astronomical knowledge in monument alignments and religious texts, continuing mathematical and engineering traditions across millennia, and developing institutional systems designed to maintain knowledge continuity. Egyptian achievements actually represent successful application of inherited knowledge systems combined with innovations adapted to local conditions and available resources rather than original development. The knowledge distribution pattern. Other classical civilizations inherited different aspects of the original knowledge base. Greek mathematics and philosophy built on older traditions. Roman engineering applied inherited principles to new projects. Chinese technological innovation combined ancient knowledge with new discoveries, and Indian astronomical and mathematical systems preserved complex calculations. The gradual decline pattern. Throughout the classical period, technological capabilities generally declined rather than improved. Precision construction standards gradually decreased over time. Mathematical and astronomical knowledge became increasingly fragmented. Advanced manufacturing techniques were simplified or lost entirely, and engineering capabilities were reduced to methods achievable with available resources. The institutional preservation efforts. Classical civilizations developed institutions designed to maintain inherited knowledge through priesthood systems preserving astronomical and mathematical knowledge, craft guilds maintaining specialized construction and manufacturing techniques, educational systems transmitting complex information across generations, and monument construction projects demonstrating continued technological capabilities. The regional knowledge specialization. As inherited knowledge became more fragmented, different regions specialized in preserving different aspects. Egypt focused on construction and astronomical knowledge. Mesopotamia specialized in mathematical and administrative systems. Greece developed philosophical and theoretical frameworks, and Rome concentrated on practical engineering and organizational methods. The lesson from classical inheritance is that the great achievements of classical civilizations represent successful management and application of inherited advanced knowledge rather than original development from primitive origins. The medieval decline. Knowledge fragmentation 2,000 to 500 years ago. During the medieval period, the institutional systems that had preserved inherited knowledge began to fail, leading to further loss of advanced capabilities and the period often called the Dark Ages. The institutional collapse. Political instability, warfare, and economic disruption destroyed many of the systems that had maintained inherited knowledge. Libraries and educational institutions were destroyed during conflicts. Craft guilds lost specialized knowledge when master practitioners were killed. Religious institutions focused on theology rather than preserving technical knowledge, and trade networks that distributed technological information were disrupted. The medieval period represents a time of knowledge loss, where civilizations struggled to maintain capabilities inherited from much earlier advanced sources, rather than primitive ignorance. The knowledge preservation efforts. Some institutions worked to preserve what remained of inherited knowledge. Monastic orders copied and maintained ancient texts. Islamic scholars preserved and developed inherited mathematical and astronomical knowledge. The Byzantine Empire maintained some aspects of classical engineering and administration, and Chinese civilization continued technological development based on inherited foundations. The technological regression. Many capabilities that classical civilizations had maintained were lost during this period. Precision construction techniques were forgotten in many regions. Advanced mathematical and astronomical knowledge became fragmented. Manufacturing standards declined as specialized knowledge was lost, and engineering capabilities were reduced to simpler methods. The regional variation. The decline occurred unevenly across different regions. Islamic civilization preserved and developed much inherited knowledge. Chinese civilization maintained technological advancement. European regions experienced more severe knowledge loss, and some isolated areas preserved specific techniques and capabilities. The lesson from medieval decline is that advanced knowledge is fragile and can be lost rapidly when institutional systems fail, leading to technological regression rather than continuous progress. The modern recovery. Rediscovering lost knowledge 500 years ago to present. The period we call the Renaissance and Scientific Revolution represents humanity's gradual rediscovery of knowledge that had been lost during the medieval decline, combined with new innovations building on recovered foundations. The Renaissance rediscovery. Beginning around 500 years ago, European civilization began recovering knowledge that had been preserved in other regions or rediscovered through archaeological investigation. This included mathematical and astronomical knowledge preserved in Islamic sources, engineering principles rediscovered through study of classical monuments, scientific methods developed to investigate natural phenomena systematically, and technological innovations building on recovered ancient foundations. The scientific revolution actually represents a period of recovery and redevelopment of capabilities that had existed in earlier civilizations, rather than humanity's first development of advanced knowledge. The archaeological awakening. As modern civilization developed more sophisticated investigation methods, we began discovering evidence of much earlier advanced capabilities, including precision construction techniques that exceed modern standards, mathematical and astronomical knowledge encoded in ancient monuments, evidence of technologies and materials science beyond current understanding, and global patterns suggesting worldwide advanced civilization. The contemporary dilemma. Modern civilization now faces the challenge of reconciling recovered evidence with established narratives about human progress. Physical evidence suggests much earlier advanced capabilities than conventional chronology allows. Institutional investment in established timelines creates resistance to evidence-based revision. Cultural identity based on assumptions about progress and modern superiority prevents objective evaluation, and economic and political interests support maintaining conventional narratives regardless of evidence. The current trajectory. We appear to be approaching technological capabilities similar to those achieved by the antediluvian civilization. This includes precision manufacturing and materials science reaching ancient standards, astronomical knowledge and space exploration, recovering ancient understanding, global communication and coordination systems, enabling planetary-scale projects, and energy technologies beginning to explore principles that ancient civilizations may have mastered. The lesson from modern recovery is that our current technological achievements may represent recovery of capabilities that humanity possessed much earlier, rather than unprecedented advancement in human history. The evidence suggests that human civilization follows cyclical patterns of achievement, catastrophe, and recovery, rather than linear progress from primitive origins to modern sophistication. This timeline explains the impossible precision and advanced knowledge evident in pyramid construction, while providing a framework for understanding our own place in the larger pattern of human development. But this raises crucial questions about what this cyclical pattern means for our future and what we can learn from the evidence of previous advanced civilizations to ensure the survival and advancement of our own society. What this means for humanity. Implications for our future. The cyclical nature of human progress. If the evidence we've examined is correct, human civilization doesn't follow the linear progression we've been taught. Instead, it appears to move in cycles of achievement, catastrophe, and recovery with each cycle potentially reaching different peaks of capability before facing destruction and having to rebuild. Looking at the evidence objectively reveals a recurring pattern. Advanced civilizations develop sophisticated technologies and global coordination. Natural catastrophes or other disasters destroy infrastructure and reduce populations. Survivors preserve fragments of knowledge while adapting to changed conditions. Recovery civilizations rebuild using inherited knowledge combined with new innovations. The cycle repeats with each iteration potentially exploring different technological paths. Rather than assuming continuous advancement, we should recognize that human achievement can be lost and must be actively preserved through institutional systems designed to survive catastrophic periods. Different cycles appear to have explored different approaches to advanced technology. The antediluvian civilization may have mastered energy systems and materials science using principles we haven't discovered. Classical civilizations developed mathematical and astronomical knowledge to remarkable levels. Our current civilization has achieved global communication, space exploration, and digital technology. Future cycles might develop capabilities in directions we haven't imagined. Each cycle faces the same fundamental challenge: how to preserve crucial knowledge and capabilities through catastrophic periods that can destroy infrastructure and reduce populations to survival levels. Understanding that advancement isn't guaranteed helps us appreciate current achievements while recognizing the importance of developing systems that can preserve knowledge and capabilities through potential future catastrophes. The cosmic threat awareness. One of the most sobering implications of this evidence is that advanced human civilizations are vulnerable to cosmic events that can destroy global infrastructure and force humanity to rebuild from surviving fragments. The geological evidence for cosmic impacts 12,800 years ago demonstrates that Earth regularly encounters cosmic debris that can cause global catastrophes. Advanced civilizations with worldwide infrastructure are particularly vulnerable to such events. Recovery from cosmic impact events requires centuries or millennia. Technological capabilities can be lost entirely if preservation systems fail. We're developing global infrastructure and technological dependence that makes us vulnerable to the same types of cosmic events that destroyed previous advanced civilizations. Modern astronomy has identified multiple ongoing threats: asteroid and comet impacts that could cause regional or global destruction, solar flares and coronal mass ejections that could destroy electronic infrastructure, gamma-ray bursts and other cosmic events that could affect Earth's atmosphere, unknown cosmic cycles that might increase the frequency of catastrophic events. Despite our advanced technology, current civilization is poorly prepared for cosmic catastrophes. Most critical infrastructure depends on electronic systems vulnerable to electromagnetic events. Global food production relies on complex supply chains that cosmic events could disrupt. Knowledge preservation systems are increasingly digital and vulnerable to technological failure. Recovery planning assumes gradual disasters rather than sudden global catastrophic events. Advanced civilizations must develop robust systems for preserving knowledge and capabilities through cosmic catastrophes or risk losing achievements when such events inevitably occur. The knowledge preservation imperative. Understanding that previous civilizations lost advanced knowledge should motivate us to develop better systems for preserving crucial information and capabilities through potential catastrophic periods. Previous civilizations encoded important knowledge in stone monuments designed to survive natural disasters and civilizational collapse. Mathematical and astronomical relationships embedded in architectural proportions. Cultural and religious traditions maintaining oral transmission of crucial information. Geographic distribution of knowledge across multiple regions and institutions. Our current knowledge base is much larger and more complex than ancient civilizations, requiring more sophisticated preservation strategies. Physical preservation of essential technical knowledge in durable formats. Distributed storage systems preventing complete loss from regional catastrophes. Educational systems ensuring crucial knowledge remains actively understood. Institutional redundancy, maintaining knowledge preservation across multiple organizations. Much of our current knowledge exists only in digital formats that are vulnerable to electromagnetic events that could destroy electronic storage systems. Technical obsolescence making digital formats unreadable. infrastructure collapse that prevents access to digital libraries, dependency on complex systems that might not survive catastrophic periods. Preparing for potential catastrophes requires identifying which knowledge is most crucial for civilizational recovery, basic scientific principles, and mathematical relationships. Essential technologies for agriculture, medicine, and manufacturing, organizational systems for coordinating large-scale projects, historical knowledge about previous catastrophes and recovery methods. Advanced civilizations must actively work to preserve essential knowledge in formats and systems that can survive catastrophic periods, rather than assuming current storage methods will always be available. The alternative technology exploration. Evidence for advanced ancient technologies suggests that our current technological development path isn't the only possible approach to achieving sophisticated capabilities. This opens possibilities for innovation that could benefit humanity while providing alternatives if our current technology fails. Ancient civilizations appear to have mastered sound and frequency technologies for construction and other applications, energy systems using natural earth properties and electromagnetic effects, materials science producing superior alloys and composites, precision manufacturing using methods we haven't identified. Rather than assuming our current technology represents the optimal path, exploring ancient principles might reveal more sustainable energy systems using renewable natural forces, construction techniques requiring less energy and producing superior results, materials with properties that exceed current synthetic capabilities, manufacturing methods that achieve precision with simpler tools and systems. Ancient technologies may have been based on natural energy fields and electromagnetic properties, acoustic and vibrational phenomena for materials manipulation, biological systems and organic chemistry for manufacturing processes, astronomical and mathematical principles for large-scale engineering. Investigating ancient technological evidence could lead to breakthrough innovations, solving current environmental and energy challenges. Alternative manufacturing approaches, reducing resource consumption. Construction techniques enabling massive projects with reduced environmental impact. Energy systems providing sustainable power without complex infrastructure. Exploring evidence for ancient technological approaches could accelerate modern innovation while providing backup systems that don't depend on our current infrastructure. The educational revolution necessity. Acknowledging the evidence for advanced ancient civilizations requires fundamental changes in how we educate people about history, human capabilities, and the nature of progress itself. Education should teach students to evaluate historical claims against physical evidence rather than accepting authoritative narratives. Recognize institutional bias and understand how it affects knowledge preservation and distribution. Apply engineering and scientific analysis to historical questions. Consider alternative explanations when conventional theories fail to explain observed evidence. Students educated with honest evaluation of evidence would be better prepared to solve complex problems by considering unconventional approaches, recognize and resist institutional bias in their own fields. Preserve and transmit knowledge effectively through potential catastrophic periods. Innovate by learning from past achievements, rather than assuming current methods are optimal. Rather than teaching that we represent the peak of human achievement, education could explore the full range of capabilities demonstrated throughout human history. Different approaches to technological development and social organization. Methods for preserving and recovering knowledge through difficult periods. Strategies for achieving sustainable advancement that survives catastrophic events. Honest historical education requires combining engineering analysis of ancient achievements, geological and astronomical evidence for dating and environmental conditions, archaeological investigation, guided by evidence rather than theoretical assumptions, cultural and mythological studies, recognizing historical preservation in traditional narratives. Preparing future generations for potential catastrophic challenges requires education that honestly evaluates evidence and teaches practical knowledge preservation and problem-solving skills. The Global Cooperation Framework. Evidence for worldwide ancient civilizations suggests that achieving advanced capabilities requires global cooperation and knowledge sharing rather than competition between isolated nations or regions. Evidence suggests that the antediluvian civilization achieved shared standards for measurement, mathematics, and construction across continents. Coordinated monument building, encoding identical astronomical information. Knowledge distribution systems ensuring important information reached multiple regions. Institutional cooperation, enabling massive projects requiring resources from multiple areas. Learning from ancient coordination methods could enable massive infrastructure projects, addressing climate change and resource challenges. Knowledge preservation systems distributed across multiple countries and institutions. Disaster preparation and recovery planning coordinated internationally. Technology development combining resources and expertise from multiple civilizations. Despite advanced communication technology, modern cooperation is limited by political competition and nationalism, preventing optimal resource allocation. Economic systems that prioritize short-term profit over long-term survival. Cultural bias and institutional resistance to learning from other approaches. Lack of institutional frameworks for coordinating global responses to catastrophic threats. Modern communication and transportation could enable real-time coordination of global projects and resources. Instant distribution of crucial knowledge and technological innovations. Rapid response systems for natural disasters and catastrophic events. Educational systems sharing knowledge and capabilities across cultural boundaries. Achieving advanced capabilities and surviving catastrophic threats requires international cooperation and knowledge sharing that transcends political and cultural boundaries. The responsibility to future generations. Understanding that previous advanced civilizations were lost carries a moral responsibility to ensure that our current achievements and knowledge survive for future generations. Having recovered evidence of lost civilizations obligates us to preserve current knowledge in formats that can survive catastrophic periods. Develop institutional systems capable of maintaining information across generations. Educate future generations about both achievements and vulnerabilities of advanced civilization. Create backup systems that don't depend on current infrastructure for essential capabilities. Rather than assuming current progress will automatically continue, we must actively work to document essential knowledge in permanent formats. Distribute crucial information across multiple geographic and institutional locations. Develop technologies and social systems that enhance rather than threaten long-term survival. Learn from previous catastrophes to better prepare for future challenges. Understanding cyclical civilization patterns means that innovation should focus on technologies that enhance rather than threaten civilizational stability. Knowledge systems that remain accessible through catastrophic periods. Social institutions that preserve cooperation and knowledge transmission. Sustainable approaches that don't exhaust resources needed for long-term survival. Recognizing previous advanced civilizations requires honest evaluation of evidence, regardless of institutional or cultural convenience. Revision of educational materials to reflect evidence rather than preferred narratives. Support for research that might challenge established theories. Acknowledgement of human achievements throughout history rather than just recent accomplishments. Each advanced civilization has an obligation to preserve its achievements and learn from previous cycles to ensure that human knowledge and capabilities continue to advance rather than being lost through preventable catastrophes. The evidence for advanced ancient civilizations provides both inspiration and warning for our current society. We have the potential to achieve remarkable things, but we also face the same vulnerabilities that destroyed previous advanced civilizations. Learning from this evidence could help us develop more robust systems for preserving knowledge and capabilities, while exploring alternative approaches to technology and social organization that could benefit humanity for millennia to come. The choice we face is whether to honestly evaluate this evidence and learn from it, or to continue protecting comfortable narratives while ignoring the lessons that previous civilizations tried to preserve for us in stone. The real timeline, humanity's true age. Rewriting the story of human achievement. After examining hundreds of pieces of evidence, from impossible precision in ancient stonework to suppressed archaeological discoveries, from professional engineering analysis to systematic institutional resistance, we must confront a profound possibility. The story of human civilization we've been taught is fundamentally wrong. The evidence integration. When we combine all the evidence objectively, geological analysis proves the Sphinx is at least 12,000 years old. Astronomical alignments point to 10,500 BC as the relevant date for pyramid construction. Engineering analysis shows that ancient achievements required technologies beyond conventional explanations. Global patterns reveal worldwide advanced civilization that conventional chronology can't explain. Professional expertise consistently concludes that primitive methods couldn't accomplish observed results. Multiple independent lines of investigation all point to the same conclusion. Advanced human civilization is much older than we've been taught, and previous societies achieved capabilities that we're only now beginning to recover. The timeline revolution. Rather than linear progress from primitive origins, human development appears to follow a pattern of advanced civilizations achieving remarkable technological and intellectual capabilities, catastrophic events, destroying global infrastructure, and reducing populations, recovery periods where survivors rebuild using preserved knowledge, gradual loss of inherited capabilities as institutional preservation systems fail, rediscovery and innovation, leading to new cycles of advancement. The institutional resistance reality. The systematic suppression of evidence supporting alternative timelines reveals that academic institutions prioritize protecting established narratives over investigating challenging evidence. Economic and political interests support maintaining conventional chronology regardless of physical evidence. Educational systems teach theoretical frameworks rather than evidence-based analysis. Media and publishing industries promote narratives that support institutional authority. When multiple independent sources of evidence consistently challenge established theories, the theories are probably wrong rather than all the evidence being mistaken. The 25,000-year civilization cycle. Based on geological evidence, astronomical calculations, and patterns of technological achievement, human civilization appears to operate on cycles of approximately 25,000 years, roughly matching the precession cycle that ancient monuments worldwide seem designed to commemorate. The current cycle timeline, 25,000 to 12,800 years ago. Advanced antediluvian civilization reaches peak capabilities, 12,800 to 11,600 years ago. Younger Dryas catastrophe destroys global infrastructure, 11,600 to 7,000 years ago. Recovery period rebuilding using preserved knowledge, 7,000 to 500 years ago. Classical period managing inherited capabilities with gradual decline, 500 years ago to present. Renaissance and modern period recovering lost knowledge. Human civilization has been cycling through periods of advancement and catastrophe for potentially hundreds of thousands of years, with each cycle exploring different technological approaches and leaving different types of evidence. The precession connection. The 25,920-year precession cycle appears to be significant because it represents a complete cycle of Earth's astronomical relationships. Ancient monuments worldwide encode precession knowledge, suggesting its importance to their builders. Climate cycles and cosmic threat patterns may correlate with precession timing. Previous civilizations may have used precession cycles to predict and prepare for catastrophic periods. The multiple cycle evidence. Archaeological anomalies worldwide suggest that the current cycle isn't the first. Artifacts and structures that appear much older than 25,000 years. Evidence of advanced capabilities in periods that conventional chronology considers impossible. Geological formations and modifications that suggest artificial origin. Myths and traditions describing multiple previous ages of human civilization. Understanding that human achievement follows long-term cycles helps explain both the remarkable capabilities of ancient civilizations and the systematic loss of knowledge through catastrophic periods. The true age of the pyramids. All evidence examined points to the Great Pyramid, and associated monuments being much older than the conventional 4,500-year timeline, with construction likely occurring during the advanced antediluvian period before the Younger Dryas catastrophe. The astronomical dating evidence. The Orion correlation precisely matches stellar positions from 10,500 BC, not 2,500 BC. This astronomical alignment was intentionally designed to commemorate a specific time period, required sophisticated understanding of precession cycles to calculate, demonstrates knowledge that supposedly wasn't developed until much later, points to construction planning during or about the 10,500 BC period. Water erosion patterns on the Sphinx and surrounding monuments are consistent with heavy rainfall periods ending approximately 7,000 years ago, most intensive erosion occurring 12,000 to 10,000 years ago, climate conditions that existed during the wet Sahara period, environmental circumstances that haven't existed during historical periods. The engineering timeline integration. Professional engineering analysis suggests construction techniques that exceed capabilities available during conventional dating periods, precision requirements that demand technologies we don't understand, project scope requiring organizational capabilities beyond ancient Egyptian resources, quality standards that indicate advanced technological civilization, the knowledge inheritance model. Rather than original construction by Pharaoh Khufu's workers, the evidence supports original construction during the advanced antediluvian period, approximately 12,000 to 10,500 BC, survival through the Younger Dryas catastrophe due to massive construction and elevated location, discovery and restoration by early Egyptian civilization, continued maintenance and modification throughout Egyptian history, gradual loss of understanding about original construction methods and purposes. The Great Pyramid represents the surviving achievement of a much older and more advanced civilization than conventional archaeology acknowledges. The Global Monument Network. Evidence suggests that the Great Pyramid was part of a worldwide network of monuments built by the advanced antediluvian civilization to preserve knowledge and mark significant astronomical cycles. The worldwide coordination pattern. Megalithic monuments on every continent demonstrate identical construction techniques using massive, precisely fitted stones, shared astronomical knowledge encoded in alignments and proportions, mathematical relationships incorporating advanced geometric principles, construction standards requiring technologies beyond conventional explanations. The antediluvian civilization operated on a planetary scale with communication systems enabling coordination across continents, transportation methods allowing movement of massive materials globally, standardized knowledge systems ensuring consistency across different regions, institutional frameworks maintaining coordination over extended time periods. The Knowledge Preservation Network. The Global Monument Network appears designed to preserve crucial, astronomical, and mathematical knowledge in permanent form, distribute information across multiple geographic locations for redundancy, encode knowledge at multiple levels of complexity for gradual rediscovery, mark significant astronomical cycles for future civilizations. The specialized function sites. Different monument complexes appear to have served different purposes. Giza, mathematical and engineering knowledge preservation. Göbekli Tepe, astronomical observation and calendar systems. Stonehenge, eclipse prediction and astronomical calculation. Angkor, stellar mapping and cosmological knowledge. Machu Picchu, high-altitude observation and seismic research. The Recovery Civilization Response. Post-catastrophe civilizations responded to these monuments by recognizing their importance and attempting to understand their purposes, building additional structures to complement or modify original functions, developing religious and cultural systems around monument significance, preserving traditional knowledge about monument builders and purposes. The advanced antediluvian civilization created a worldwide system for preserving and transmitting knowledge that individual post-catastrophe civilizations have been rediscovering and interpreting throughout history. The technology development paths. Evidence suggests that different cycles of human civilization have explored different approaches to technological development, achieving advanced capabilities through various methods, rather than following a single progressive path. The antediluvian technology path. The lost civilization appears to have mastered sound and frequency technologies for materials, manipulation, and construction, natural energy systems, using Earth's electromagnetic and gravitational properties, precision manufacturing using principles we haven't identified, materials, science producing superior alloys and composites, transportation methods that left no mechanical infrastructure evidence. While modern civilization has focused on electronic and digital technologies for communication and computation, chemical and nuclear energy systems for power generation, mechanical engineering for construction and transportation, synthetic materials and industrial manufacturing processes, space exploration, and electromagnetic technologies, the classical period inheritance. Post catastrophe civilizations preserved fragments of antediluvian technology while developing their own innovations. Mathematical and astronomical knowledge maintained in religious institutions. Construction techniques adapted to available materials and reduced capabilities. Organizational systems scaled down from global to regional coordination. Educational methods preserving complex knowledge through oral and written traditions. The modern recovery trajectory. Our current civilization is rediscovering some antediluvian capabilities while developing others through different methods. Precision manufacturing approaching ancient standards using different techniques. Global communication and coordination using electronic rather than unknown ancient methods. Astronomical knowledge recovered through telescope and space exploration technologies. Material science beginning to achieve properties that ancient alloys demonstrated. The future development potential. Understanding different technological paths could enable hybrid approaches combining ancient principles with modern innovations. Alternative energy systems, using natural forces that ancient civilizations may have mastered. Construction techniques requiring less energy while achieving superior results. Knowledge preservation systems that survive catastrophic periods more effectively. Human technological development can follow multiple routes to achieve advanced capabilities, and exploring evidence for alternative approaches could accelerate current innovation while providing backup systems for catastrophic periods. The implications for human potential. Recognizing the true age and achievements of human civilization reveals that our species' potential extends far beyond what current educational and cultural systems suggest. The capability expansion. Evidence for advanced ancient civilizations demonstrates that humans have previously achieved precision engineering that rivals or exceeds current standards, global coordination and cooperation on massive projects, sustainable technologies that operated for millennia without environmental destruction, knowledge preservation systems that survived catastrophic periods, cultural and institutional frameworks that maintained advanced capabilities across generations. Rather than representing the peak of human achievement, our current civilization is recovering capabilities that our species has demonstrated before, while developing new capabilities that could exceed previous achievements. The educational revolution necessity. Recognizing true human potential requires teaching accurate history based on evidence rather than convenient narratives. Encouraging innovation by showing what humans have accomplished under different circumstances. Developing critical thinking skills that can evaluate evidence objectively. Preparing students for both opportunities and challenges that cyclical civilization patterns suggest. The institutional reform implications. Understanding cyclical civilization requires knowledge preservation systems designed to survive catastrophic periods, international cooperation frameworks that transcend short-term political considerations, research institutions committed to evidence-based investigation rather than paradigm protection, educational systems that prepare populations for both advancement and survival challenges. The responsibility recognition. Acknowledging previous advanced civilizations creates obligations to preserve current knowledge and capabilities for future generations, learn from previous catastrophes to better prepare for future challenges, develop technologies and social systems that enhance rather than threaten long-term survival, honestly evaluate evidence about human history and potential, regardless of institutional convenience. Our species has achieved remarkable things before and can do so again, but realizing this potential requires honest evaluation of evidence, effective knowledge preservation, and institutional systems designed for long-term survival rather than short-term convenience. The evidence reveals that human civilization is much older, more complex, and more remarkable than conventional narratives suggest. Understanding this true timeline could inspire greater achievements while providing crucial lessons for ensuring that current knowledge and capabilities survive for future generations to build upon rather than having to rediscover after. Catastrophic loss. What this means for humanity, the future of our species. Standing at the crossroads of truth. After examining hundreds of pieces of evidence across multiple disciplines, we arrive at a profound moment of choice. The evidence clearly demonstrates that human civilization is older, more advanced, and more vulnerable than we've been taught. The question now is whether we'll have the courage to accept these discoveries and learn from them, or continue protecting comfortable illusions while ignoring crucial lessons from our past. Throughout this investigation, we've discovered impossible precision in ancient construction that exceeds modern capabilities, astronomical knowledge encoded in monuments pointing to much earlier dates, geological evidence proving major structures are thousands of years older than claimed, professional engineering consensus that primitive methods couldn't accomplish observed results, systematic suppression of evidence by institutions protecting established narratives, and global patterns suggesting worldwide advanced civilization before recorded history. What this evidence convergence means for humanity is clear. We possess capabilities that we've achieved before and lost through catastrophic events. Understanding this pattern could help us both reach greater heights and avoid repeating the mistakes that led to previous civilizational collapse. We can either continue protecting institutional narratives that ignore physical evidence, honestly evaluate discoveries that challenge comfortable assumptions about progress, learn from previous advanced civilizations to enhance our own capabilities, or develop systems that preserve knowledge through potential catastrophic periods. The lesson from our investigation is that the truth about human capabilities and history is more remarkable than fiction, but accessing this truth requires intellectual courage and institutional reform that prioritizes evidence over convenience. The cyclical warning, learning from catastrophe. Perhaps the most sobering lesson from our investigation is that advanced human civilizations have been destroyed before by events beyond their control. Understanding these patterns could help us prepare for similar challenges while avoiding the vulnerabilities that led to previous collapse. Evidence suggests that advanced civilizations are vulnerable to cosmic events including asteroid impacts, solar flares, and gamma-ray bursts, climate catastrophes triggered by astronomical cycles or cosmic impacts, social collapse, when institutions fail to maintain knowledge and cooperation, resource depletion from unsustainable technologies and population growth, and knowledge loss, when preservation systems fail during crisis periods. Previous catastrophes teach us that the antediluvian civilization appears to have anticipated the Younger Dryas catastrophe and attempted to preserve crucial knowledge through monument construction designed to survive natural disasters, knowledge encoding in permanent materials, and mathematical relationships, geographic distribution of information across multiple locations, educational systems designed to maintain complex information across generations, and institutional frameworks for coordinating global response to challenges. Modern civilization faces similar risks with potentially greater consequences. Electronic infrastructure vulnerable to electromagnetic events, global supply chains that could collapse during cosmic catastrophes, digital knowledge storage that might not survive technological disruption, centralized institutions that could fail during crisis periods, and environmental degradation that reduces our civilization's resilience. Learning from previous catastrophes requires robust knowledge preservation systems using multiple formats and locations, institutional redundancy, ensuring that crucial capabilities survive regional disasters, sustainable technologies that don't exhaust resources needed for long-term survival, international cooperation frameworks that can coordinate global responses to challenges, and educational systems that prepare populations for both opportunities and threats. The lesson from catastrophe patterns is that advanced civilizations must actively prepare for cosmic and environmental challenges or risk losing their achievements when such events inevitably occur. The technology integration opportunity. Evidence for advanced ancient technologies suggests that our current development path isn't the only route to sophisticated capabilities. Integrating principles from previous civilizations could accelerate innovation while providing alternative approaches that enhance rather than threaten long-term survival. Ancient civilizations appear to have mastered sound and frequency technologies for construction and materials manipulation, energy systems using natural electromagnetic and gravitational properties, precision manufacturing that achieved tolerances, matching modern standards, materials science, producing alloys and composites with superior properties, and transportation methods that required minimal infrastructure while moving massive loads. Rather than abandoning current technology, we could explore acoustic methods for construction and manufacturing that reduce energy requirements, investigate natural energy systems that provide sustainable power without complex infrastructure, develop precision techniques that achieve ancient standards using modern understanding, research materials, science principles that ancient civilizations may have discovered, and create transportation systems that combine ancient principles with modern capabilities. Investigating ancient technological evidence could lead to breakthrough innovations in sustainable energy production, construction techniques that achieve superior results with reduced environmental impact, manufacturing processes that require fewer resources while achieving higher precision, materials with properties that exceed current synthetic capabilities, and alternative approaches to problems that current technology hasn't solved effectively. Combining ancient principles with modern innovation could create energy systems that are both advanced and sustainable, construction methods that achieve precision while minimizing environmental impact, transportation technologies that reduce infrastructure requirements, knowledge preservation systems that survive both digital and physical catastrophes, and social institutions that maintain cooperation through challenging periods. Understanding different technological approaches could solve current environmental and resource challenges more effectively, provide backup systems when current technologies fail or become unavailable, open new fields of research that conventional science hasn't explored, create more resilient technological foundations for long-term civilizational survival. The lesson from technology integration is that exploring evidence for alternative technological approaches could accelerate current innovation while creating more robust and sustainable foundations for human advancement. The global cooperation imperative. Evidence for worldwide ancient coordination suggests that achieving advanced capabilities and surviving catastrophic challenges requires international cooperation that transcends political, cultural, and economic boundaries. The antediluvian civilization appears to have achieved shared standards for measurement, mathematics, and construction across continents, coordinated monument building that preserved knowledge in multiple locations, knowledge distribution systems that ensured crucial information reached all regions, and institutional frameworks that maintained cooperation across different cultures and geographic areas. Learning from ancient coordination methods could enable massive infrastructure projects addressing climate change and resource challenges, knowledge preservation systems distributed across multiple countries and institutions, disaster preparation and recovery planning, coordinated internationally, technology development that combines resources and expertise from multiple civilizations, and educational systems that share knowledge and capabilities across cultural boundaries. Despite advanced communication technology, modern cooperation is constrained by political competition and nationalism that prevents optimal resource allocation. Economic systems that prioritize short-term profit over long-term survival, cultural bias and institutional resistance to learning from other approaches, and lack of frameworks for coordinating global responses to catastrophic threats. Modern capabilities could enable coordination that exceeds ancient achievements through real-time global communication for instant coordination of resources and responses, transportation systems that move people and materials anywhere on Earth within hours, information systems that distribute knowledge and innovations instantly worldwide, and monitoring technologies that provide early warning for cosmic and environmental threats. Effective global cooperation requires international institutions designed for long-term survival rather than short-term political advantage, economic systems that support cooperation and knowledge sharing rather than competition and hoarding, educational frameworks that prepare populations for both individual achievement and collective survival, and cultural systems that value human advancement over tribal identity and nationalistic competition. The lesson from cooperation imperatives is that achieving advanced capabilities and surviving catastrophic challenges requires global cooperation that prioritizes species survival and advancement over political and economic challenges. Competition. The educational revolution for human potential. Understanding the true scope of human achievement throughout history requires fundamental changes in how we educate people about capabilities, progress, and responsibility to future generations. Conventional education teaches linear progress from primitive origins to modern sophistication, cultural superiority of current civilization over previous achievements, technological determinism that assumes current methods are optimal, institutional authority rather than evidence-based critical thinking and competition, and nationalism rather than cooperation and species survival. Teaching accurate history and honest evaluation of evidence would prepare students to recognize and develop the full range of human capabilities demonstrated throughout history, solve complex problems by learning from previous achievements and failures, preserve and transmit knowledge effectively through potential catastrophic periods, cooperate globally on challenges that require species-level coordination, and innovate by combining ancient principles with modern understanding. Rather than assuming current limitations represent permanent human constraints, education could explore construction and engineering capabilities demonstrated by previous civilizations, organizational and cooperation methods that achieved global coordination, knowledge preservation systems that maintained complex information across millennia, technological approaches that achieved advanced results using different principles, and cultural and institutional frameworks that supported long-term civilizational survival. Education focused on evidence evaluation would teach students to distinguish between institutional narratives and physical evidence, recognize bias and agenda in information sources, apply practical analysis to theoretical claims, integrate knowledge from multiple disciplines for comprehensive understanding, and think in long-term rather than short-term frameworks about challenges and solutions. Understanding cyclical civilization patterns would prepare students for preserving knowledge and capabilities for future generations, responding effectively to catastrophic challenges that threaten civilizational continuity, developing technologies and institutions that enhance rather than threaten long-term survival, and cooperating globally on challenges that require species-level coordination. The lesson from educational revolution is that preparing humanity for future challenges requires education that honestly evaluates evidence about human capabilities while developing critical thinking skills and long-term responsibility. The species survival framework. Understanding that advanced civilizations can be lost forces us to think beyond individual, national, or even generational concerns to consider what's required for long-term human survival and advancement. Human civilization faces multiple existential threats, including cosmic events that could destroy infrastructure and reduce populations globally, environmental degradation that could undermine the foundations of technological civilization, social collapse from institutional failure and cooperation breakdown, knowledge loss from inadequate preservation systems during crisis periods, and resource depletion from unsustainable technologies and population growth. Rather than assuming continued progress, we must actively work to develop robust systems for preserving essential knowledge through catastrophic periods, create institutional frameworks that maintain cooperation and coordination during crises, build technological foundations that enhance rather than threaten long-term survival, establish backup systems that don't depend on complex infrastructure for essential capabilities, and prepare for both opportunities and challenges that cyclical patterns suggest. Species survival planning requires thinking beyond immediate concerns to consider knowledge and capabilities that must be preserved for future recovery periods. Institutional systems that can maintain continuity across centuries or millennia. Technological approaches that remain sustainable over extended time periods. Educational methods that prepare populations for both advancement and survival challenges, and cooperation frameworks that transcend political and cultural boundaries. Building civilizational resilience requires distributed systems that prevent single points of failure during catastrophic events, redundant capabilities that ensure essential functions continue during crisis periods, adaptive institutions that can respond effectively to changing circumstances, sustainable technologies that don't exhaust resources needed for long-term survival, and knowledge systems that remain accessible without complex technological infrastructure. The lesson from species survival is that ensuring long-term human advancement requires thinking and planning beyond individual lifetimes to develop systems that can preserve and build upon achievements across multiple generations, potential catastrophic periods. What you can do. The evidence we've examined reveals both extraordinary human potential and sobering vulnerabilities. But this knowledge is only valuable if it leads to action that enhances our civilization's capabilities while protecting against the challenges that destroyed previous advanced societies. Individual actions that matter include educating yourself about evidence-based history rather than accepting institutional narratives without evaluation, supporting research that investigates challenging evidence even when it conflicts with established theories, developing skills and knowledge that would remain valuable during technological disruption, learning from ancient achievements to enhance your own problem-solving capabilities, and preserving important knowledge and skills that might be lost if current systems fail. You can contribute to human advancement and survival by demanding transparency and evidence-based investigation from educational and research institutions, supporting international cooperation on challenges that require global coordination, developing and promoting technologies that enhance rather than threaten long-term survival, teaching others to think critically about evidence and resist institutional bias, and planning and preparing for both opportunities and challenges that historical patterns suggest. Community and institutional engagement includes advocating for educational reform that teaches evidence-based critical thinking, supporting institutions and organizations committed to honest investigation, regardless of challenging implications, promoting international cooperation and knowledge sharing across cultural and political boundaries, developing local resilience and knowledge preservation systems that could survive regional catastrophes, and creating networks of people committed to preserving and advancing human knowledge and capabilities. Understanding that we're part of a larger pattern of human achievement and potential loss creates obligations to preserve current knowledge and capabilities for future generations. Learn from previous civilizations to avoid repeating their mistakes. Develop systems that enhance humanity's chances of surviving future challenges, and build upon, rather than ignore the achievements of previous advanced societies. The lesson from individual action is that while the challenges facing human civilization are enormous, individual actions that promote evidence-based thinking, international cooperation, and long-term planning can contribute to species survival and advancement. The truth will set us free. The evidence we've examined throughout this investigation reveals that human beings are capable of far more than our current educational and cultural systems suggest. We've achieved remarkable things before, and we can do so again, but only if we have the courage to learn from our past and plan wisely for our future. The pyramids of Egypt stand as monuments to capabilities that we're only beginning to recover. They were built by people who understood principles that we've forgotten, using technologies that we don't recognize, preserving knowledge that we need to rediscover. We face the same opportunities and threats that previous advanced civilizations confronted. We can either learn from their achievements and failures, or repeat the cycle of advancement followed by catastrophic loss. The evidence is clear, the patterns are recognizable, and the lessons are available. What happens next depends on whether we choose truth over comfort, evidence over authority, and long-term thinking over short-term convenience. The mystery of who built the pyramids isn't just about ancient history, it's about understanding what human beings are truly capable of achieving when we combine knowledge, cooperation, and wisdom about the challenges we face as a species. The answer to that mystery could determine whether our current civilization joins the ranks of advanced societies that preserve their knowledge for future generations, or becomes another cautionary tale about what happens when people forget the lessons that their ancestors tried so hard to preserve. The choice, as always, is ours to make. Thank you for joining this investigation. The truth about human history and potential is more remarkable than any fiction, but discovering it requires the courage to question everything we've been taught and the wisdom to learn from everything we discover. What will you do with this knowledge?